All right, I guess I get to start it off. Hi, welcome to session 2 of StanCon 2020. It doesn't matter what time your clock says with us. I'm Daniel Lee, one of the organizers of the conference this year. I have the honor of chairing the session. I've been a STEM developer since 2011. For those keeping track, that's pre-version 1.0. I used to work at Columbia University and now I'm working at Generable. Co-chairing this session is Martin Modrak. If you're on Discord, you've seen his posts. He's the STAN community manager at the Institute of Microbiology of the Czech Academy of Sciences. Thank you very much for coming to this year's STAN conference. 2020, it's been quite a year. Thank you for sticking with us as we've changed direction for this year's conference. The organizing committee was really happy to see such a global turnout around this conference. This year we have more than 330 registrants. This is the biggest StanCon yet. There are people here from 40 countries. We were able to award 35 scholarships to attendees in 18 countries. A quick roll call, if you feel like it, put your country in the chat window. It looks like we have 155 people here. Whoa, we've got people from all over. This is awesome. This year's StanCon would not have been possible without the generous gifts from our 4 sponsors, Metrum Research Group, Jumping Rivers, Hoxo M Incorporated, and Generable. Metrum Research Group, established in 2004, is a global leader in biomedical modeling and simulation. Metrum has provided strategic decision-making for over 200 companies across more than 700 projects. At Metrum Research Group supports their clients in advancing drug development programs by supplying them with the highest quality scientific expertise. One moment, I forgot to screen share. Oh, there we go. All right, the second sponsor we have is Jumping Rivers. Jumping Rivers are a UK consultancy company. Their services include training, infrastructure setup, and modeling. Their consultants come with over 40 years combined experience in STAN, R, Python, Scala, and other programming languages, and have worked with some of the largest and smallest companies in the world. Hoxo M Inc. is a Japanese-based company that supports all customers who wish to utilize data through state-of-the-art academic research and advanced implementations so that the clients can quickly, accurately, and rationally make decisions based on their data. They have published a book in the Japanese language that uses STAN. And Generable, our 4th sponsor, is working on improving success rates in oncology clinical trials. The Generable platform makes well-calibrated predictions of treatment efficacy from early clinical data, including patient-level longitudinal tumor measurements, status of key mutations, and other patient-level information. The models were trained on over 6,000 patient records of cytotoxic, growth inhibitor, and IO drugs and combinations. Each of these companies are involved with STAN, and we appreciate the additional financial support they have provided. There is one other person the organizers need to thank. Sally and the Kinetics team based in the UK put in an incredible effort given the short notice and complex logistics. Without her support, we wouldn't have been able to pull this off. So thank you. You can find her on the chat all throughout the day. And finally, I have a few notes about the sessions. We will be enforcing the code of conduct, and if someone is in breach of this, we will follow the non-focused complaint mechanism. That said, if an issue arises, please feel free to contact one of the members in the organizing committee or one of the moderators, and you should be able to see them with the star on the chat. We ask that you be excellent to each other. We have question and answer sessions for the developer talks, plenary, and the contributed talks. If you'd like to ask a question, please ask using the questions bar on the side in the Remo platform. We'll take a look as we start each Q&A. After the session, the speakers will be on the first floor at the tables with their names on it. There's also one poster this session. The poster will also be on the first floor, and you can walk around to other floors. And for a quick Remo etiquette, please try not to block a table. Only 5 of the 6, please only sit down if there are 5 out of 6 slots at each table. If there are 6 people at the table, no one else can get into the conversation. So we ask that you move on to a different table. And it would be nice if you added a photo to your Remo profile so people can find you, and not just look at your icon, your initial. And next year's StanCon will be hosted in the West Coast as we originally planned for this year. Our hosts at the Oregon State University have offered their venues for the conference next year. All right. With that, we'll start the session with an update from the Code of Conduct Working Group. I guess I'm ahead of schedule a little bit.
Hey StanCon, I'm Steve Bronder.
And I'm Lauren Kennedy.
So this year, the SGB prioritized making a Stan Code of Conduct. Lauren, myself, and another Stan community member formed a committee to build the Stan Code of Conduct based on the NUM-focused Code of Conduct, but modified it to reflect the needs of the Stan community.
Steve and I have been hard at work. We now have a draft code of conduct for the community, and this is where you come in. We'll post our draft on the Stan discussion forums. We encourage you to take a look, think about whether it reflects and meets the needs of the community that you'd like to be a part of.
We'll be taking comments and suggestions on the Code of Conduct when we post it on September 13th. Comments will be sent via an anonymous Google form so you can give us your honest opinion.
After September 13, Steve and I will review all the submissions. Depending on how many we get, we'll try and group them by similar themes. Where we can, we'll update our Code of Conduct with your great suggestions, and where we can't, we'll provide clear justification for why not.
At this point, we will send a report and the finalized Code of Conduct to the SGB. The SGB will then vote on it and announce it to the community. It may not be perfect, but we hope that this Code of Conduct will be something the community feels proud of and represents a community we are proud to be in.
Thank you so much for trusting us with such an important job, and enjoy the rest of the conference.
See you guys.
Thanks, Steve and Lauren. If you have any questions or comments, please find Steve during the break. I think he'll be here. I don't know if Lauren will also be here. If she is, Lauren, if you're here, please make yourself known on the chat. All right, next up, we have an update from the STAN governing body. The STAN governing body is intended to be a transparent body in service of the STAN community and the electorate.
Hi, I'm Jonah Gabry. I'm a statistician and researcher at Columbia University and one of the STAN developers and a member of the STAN governing body, the SGB. We're each going to introduce ourselves and then talk a little bit about what we've been working on this year. Next is Leah.
Hi, I'm Leah Comment. I'm a biostatistician and a researcher in Bayesian causal inference and decision making at Foundation Medicine Incorporated, and I'm going to be discussing the community engagement project.
Hi, I'm Imad Ali. I'm a statistician working as a data scientist at PlayStation, and I'm going to be talking about what we're working on with regards to improving the website.
Hi, and I'm Bill Gillespie. I'm a pharmacometrician. I work at Metrum Research Group. I'm particularly interested in the development and application of open source tools for Bayesian analysis of pharmacometric data, and have been working on developing some extensions to STAN for those kinds of applications.
Hello, my name is Sue Marquez. I'm a statistician working as a data scientist at the Rockefeller Foundation, where I've been using Bayesian statistics for projects on geospatial analysis. And I'll be discussing a couple of miscellaneous items, but mostly about the governance and the role of the SGB.
All right, so I'm going to talk about briefly the voting proposal that we have. So historically, STAN has functioned without any official mechanism for resolving disagreements among developers. And this can really put a drag on the development process, even though for the most part, things have worked successfully. We don't want to impose anything too heavy-handed, so we've introduced a proposal that is somewhat inspired by the Apache project's voting system. Ours is a bit simpler. And this would put into place a voting system for developers as a way to resolve any disagreements over the technical direction of the project. You can find this proposal in the STAN governance category on the STAN forums, and we'd really love feedback not just from the current STAN contributors, but also from anyone who's thinking about potentially contributing to STAN, or just anybody who's interested in the future of STAN development. There's also another proposal that we have for a new STAN code of conduct, but you'll be hearing about that separately from our the SGB's appointed code of conduct committee, who's done a great job on that. All right, Leah?
Hi, I'll be talking about community engagement. So from the very beginning, the STAN governing board was really interested in looking for ways to empower users and developers. We feel like having a really top-down management style isn't great for the project, and honestly, we've kind of outgrown it, that. It's just not feasible anymore. So we know that there are a lot of people that are committed, passionate users of STAN that have a lot of enthusiasm and know-how to get some things done. And we want to make it easier for those people to self-organize and come together and work on what's important to them. So earlier this year, we requested feedback on a proposal that would recognize these people, where we sort of proposed this idea of a STAN contributor. And this would be a mechanism to thank them for all their work on STAN, and also to give increased visibility so those people could sort of connect and self-organize over issues they care about. Based on feedback from the community, we're actually going to be rolling this into the technical developer voting system that Jonah was just talking about. And so we have a community module that we're going to be proposing within the STAN development team. And this type of recognition isn't unprecedented even in the STAN project, but it's going to be encouraging more people who are committed to STAN's future to put themselves forward and really connect over these issues. So if you're, for example, interested in creating educational content for STAN, this should make it easier to find people with similar interests. We hope that by featuring these individuals, giving them a platform to talk about their work, we can catalyze some of these connections. And it also gives dedicated users some representation with respect to the overall direction of the STAN project. So thank you to all who commented and gave us feedback on these ideas.
Cool. So, so everyone's well aware that the website could use some work. We've been making some progress towards website redesign. Currently, we gathered a bunch of really useful feedback from the STAN community on Discourse. And some of the key areas that people sort of highlighted are things like having quick start guides for new users and popular interfaces like R and Python, having a playground for users to interact with STAN without having to like go through the hurdles of installing it on their own machine. So that's sort of something similar to what Rust has on their website. Improving the ability to discover what's changed and what new features have been added with new releases. And defining the site flow for new and returning users and new and returning developers to make sort of information easily accessible for them. So the next step we're working towards is finding a developer that can address aspects of functional, graphical, and technical design, and work towards redesigning a website that can easily be maintained by the STAN developers. It's pretty challenging since, as everyone's well aware of, STAN is a project that's not really just a language itself, but it's like an ecosystem of a bunch of different languages and packages. But overall, we're headed in the right direction with the website redesign, and thanks to everyone who's been contributing their thoughts and ideas about how to improve the website.
Hi, I was going to take just a little bit of time to talk about our relationship with NumFocus. The STAN project is funded through NumFocus, which functions as a fiscal sponsor for activities. Now, NumFocus itself is a nonprofit corporation that provides us with a fiscal home, as well as a fiscal home for several other open source software development projects. They help us with finances. They also offer services to help with things like conference organization, for example. As part of my role as a board member, I act as a liaison with NumFocus, and in that role, I help to facilitate things like payments for various expenses incurred by the STAN project, as well as to direct donated funds to our NumFocus account. For example, I arranged for STAN to participate in the GitHub Sponsors Program. And I guess with that in mind, just a reminder to everybody that if they would like to contribute funds to the STAN project, you can do so through links at either the STAN website or through the various GitHub sites associated with the STAN project.
Great, and I'll be discussing briefly some miscellaneous items regarding how the SGB is transparent in the sense that all the decisions that we take are reported on a monthly basis in our communication forums. So if you have any questions or have a proposal that you would want to discuss with the SGB, looking support or some feedback, we're always open to that. And over the last months, there have been a few projects that have been brought to the attention of the SGB looking for support. And so we've, give careful advice as well as making sure that this SGB builds a skeleton for the next SGB members, because we want to make sure that anybody who comes on board and is interested in developing the future of this project has all the tools that they need in order to continue the work that we're currently doing. And that includes the contributor proposal, the website redesign, the sponsorship programs. So all these programs are something that we continue to report on, and we will love feedback on how well we're doing in transparency for you and the community, and what you would want to hear from us as well. So I really thank you all for your presence here at StanCon, and I hope to see you hopefully in person next year. So thank you, everybody.
Thanks, everyone.
Thank you to the SGB for that insightful video. Thank you for being so transparent. Jonah, are you around? Can I invite you up to answer this question in the Q&A?
Yes, hi. Thanks, Leah. Let me take a look. Oh yeah, Mohammed asks, do you have some collaboration projects with the R Consortium or any other R entity? We don't have like a formal relationship with R entities, but we do have kind of informal relationships with some. We know the people at our studio and talk with them somewhat regularly. The R Open Sci Foundation, we have supported their grant one of their grant applications, and are in communication with them about how we can have good procedures in place for testing R packages that implement Bayesian inference and stuff. So yeah, we do have some good connections with some of the entities in the R world, although there's not any like official links between the organizations, but we're in communication with them, definitely. Good question. If there's any other questions for the STAN governing body, I guess now's the right time for that, right?
Yeah, we can take a couple minutes since we're a little ahead of schedule.
I can also put some links in the chat to some of the other things that were mentioned in the STAN governing body talk. If you haven't seen already, I put the link to Lauren and Steve's code of conduct proposal, and Sue added the link to the website redesign discussion. For anybody who hasn't been to the STAN forums, I'll put that link in the chat now. And if you go to the STAN governance category, you can see the updates from the STAN governing body, some of the various stuff that we've been talking about here.
All right. Thank you, Jonah.
Yeah, thanks.
I don't see any more
Can
questions.
I just say one more thing on behalf of the SGB, but also just everybody. Thank you to you, Daniel, and Sue, and Simon, and Kelly, and Sally, and every, I don't know who else's name I missed, but everybody who organized this conference. And it's been great to see this come together after getting thrown for a loop by the pandemic. So thank you.
You're welcome.
All right. Thanks, everyone.
All right. Now we're going to have the six quick pitches for the talks that were available for this session. So the 6 contributor talks. They're 1-minute talks that summarize the 6-minute talks. Sorry about that.
What we're interested in estimating in our paper is the distribution of crop yields. We're interested in this because it's needed to get the premiums for crop insurance. And from a statistical perspective, we're estimating spatial models. And so we're estimating a linear time trend for every county. And each county has different parameters, but we're letting the parameters be correlated across space. And we're using Bayesian methods to estimate the correlation across space. So it's a Bayesian hierarchical model, and we're using STAN to do this because we tried MCMC It was just simply too slow. And so Stan lets us do it. Stan is still a little slow, but we're successful in estimating the model.
Hi, would you like to learn more about a multivariate synthetic control to estimate missing data? Well, you've come to the right place. My name is Sean Pinkney. I'm a Senior Director of Data Science at ComScore. This model was created in collaboration with Gaurav Shahani and Tyler Morrison, also at ComScore. It's a really neat model. It extends synthetic control to a multivariate setting and using the correlation across those multivariate series to estimate completely missing data. I hope you can join. Looking forward to it. Thank you.
Hi, everyone. My name is Armin Oganesian. I'm a fifth-year biostatistics PhD candidate at the University of Pennsylvania. Most of my research focuses around developing non-parametric Bayesian solutions to common causal inference modeling challenges, particularly those that arise in health economics. But here, for this talk, I'm going to back up a bit and talk about the value that Bayesian modeling can add, even with some simple parametric models. So I'll go through a partial pooling prior synthetic example that takes heterogeneous conditional average treatment effects and then shrinks them towards a homogeneous causal effect estimate. And then I'm going to discuss using priors for sensitivity analyses around causal identification assumptions. So if you think there's some unmeasured confounding, how you might proceed if you want to express your prior belief about the direction and magnitude of that unmeasured confounding. Thank you.
So as a quick reminder, I talked about building effective uncertainty visualizations with TidyBayes and ggdist, which are R packages that allow you to use BRMS and RStanArm and STAN models with ggplot. I talked about strategies for building effective uncertainty visualizations, including a sort of grid condition munge plot strategy that I use for building a large number of different types of uncertainty visualizations, and also hinted at some of the other things that you can do with TidyBayes, like munge posteriors into long format data tables easily, and visualize priors and analytical distributions in addition to distributions derived from posterior samples. In summary, TidyBayes and ggdist provide geoms and stats and a workflow for custom uncertainty visualization creation, as well as in the future integration with posterior.
Do you use tidyverse with packages like dplyr, tidyr, per, and ggplot? Do you use pipelines in your workflow to make it more human readable? Wouldn't it be nice to do this in RStan where you would have a model to filter, select, and create an output? Well, this fails pretty badly right now. Shredder is here to help. With Shredder, you can create RStan pipelines using new domain-specific verbs like select, filter, and thin to create your outputs. Come to the talk to learn how to convert pipelines using tidy-like verbs for RStan and speed up your interrogation and post-processing of the models, and scale your workflow to seamlessly compare multiple models at once. Shredder, introducing our pipelines to Stan.
Hi, I'm Ben Goodrich, and hopefully you don't need any reminder as to what my presentation was about, because it's literally about doing away with using prior density functions. And the alternative I advocate is to use a prior transformation using a quantile function that maps a random variable p into the random variable theta, which is the quantity of interest. So if there were no data, this would be the entirely standard approach for drawing from a prior distribution that is characterized by that quantile function. But once you condition on data, the posterior distribution of p is no longer uniform, and the posterior distribution of theta is updated conditional on the data. And this approach allows you additional flexibility to use distributions that are not named or famous. I talk about in the second half an approach where if you can elicit a prior median and maybe a couple other prior quantiles, we can run a quantile function exactly through those points, and the user can use it in the transform parameters block of their STAN program. So hopefully we can get a discussion going about those ideas. Thanks.
All right, so those were the 6 talks that we'll have a discussion about after the plenary. If anyone would like to grab a cup of coffee, this would be a great time right now. We'll wait a minute or two before we start the developer talk sessions. And since we're a little ahead of schedule, I'll give you a little background on this, a quick little background on this logo that we use for StanCon 2020. It was actually one of the prototypes for the current logo, and including down to the color scheme. So this was one of the ones that were proposed, and we went with the red one in, I believe, 2015. And, you know, as a retro thing, we decided to bring it back. So that's where this is coming from. Let's see. And Aki, are you available yet? If you are, we can start this a little early.
Just a sec, I'll put some light on the hot talk here. Okay, now you should be able to see me better.
Hey, Aki, how you doing?
Fine.
Glad you're here with us. Do you want to take a minute to summarize your talk?
Yeah, so it was Måns Magnusson who was supposed to give the talk. So he's been doing most of the work for posterior database. The idea is that there are several different use cases where we need a lot of different model plus data combinations. So posterior is both model plus data. And these use cases are, for example, when doing algorithm development, testing whether the implementation actually works, whether new algorithms, methods work. But we can also then use this for testing speed of STAN, like in a regression testing type of things. And then also, of course, if we collect these models, we should then annotate them so that it's not just that we run some algorithm for 400 models, but we can also learn which type of models some specific approximation works better. Or if people find these, they can possibly use them also as a basis for their own models. So we should also check that they are kind of following good practices, except for some models we want to actually be difficult for any algorithm, so that there are possibilities also for diagnostics. And where did Daniel go? Okay, so I can see the Q&A questions.
Yeah, I'll step up for Daniel. Maybe his connection is down or something. Okay. Daniel is back. Okay.
Yeah, thanks, Martin. Sorry about that. Lost connectivity. You know, I have a couple questions. Did you answer the one from Ryan Giordano? Oh, so where did Daniel go? Thanks.
Yeah, that's the top question. So I didn't have time yet to answer anything. We were just wondering, where did you go? So no, it's not. So the standard example models is not that well graded. I think it's the posteriordb is not necessarily replacing that, although like some of the models could be removed from example models, but it's also currently the example models is not actually that good set of models. And it's we'll also notice that like in some papers where people have then picked models from examples models, unfortunately they've started with the first directory ARMM, which is actually mostly just linear regression or GLMs, way too simple and not that interesting. So posteriordb tries to be also more diverse for testing different things, and with tags making it easier to have then suitable sets for different testing use cases. But I think that then we should also consider about this example models directory and how it is connected to case studies and so on.
I've got a question for you. If I wanted to contribute a posterior to this posteriordb, what licenses do the code and data sets have to be in order for it to be accepted and compatible?
I can't remember directly, so I would need to also check what we had. So we haven't considered whether they like what should be the licenses for the Stan code, but it should be at least like quite permissive license. But that's a good question. So we need to add to our contribution guidelines comment about that.
All right, great. Let's take two more questions. One sent from Oriole. How were Pyro and TensorFlow probability chosen? And would you consider adding Julia Turing support also?
So there are transpilers from Stan code to Pyro and TensorFlow probability. And that was the reason that they are the first examples. But of course, we are happy to support other frameworks. So the posteriordb, it has also kind of different levels. That one level is making this framework to make it easier to test different, or to compare to different posteriors. So, and it doesn't mean that we should have then every possible model in every possible language. You can test sometimes like these algorithms, even if it's in a different language. But then it's of course helpful that sometimes there are also type of models that like Stan can't handle at all, and then they can be handled in other frameworks. And of course, this is like hopefully can grow that like the other PPL framework, people can build bigger library for the models they like to have. But of course, for the articles doing different kind of comparisons, it would be useful to have some kind of common sets people are using.
Thanks. And the last question, also asked by Ryan Giordano, are there other public example model repositories to be aware of? And I'll tack onto that. Considered incorporating those into the posteriordb.
So now then, again, a lot of the work Måns and the other contributors have been doing is the framework to make it easy to use these. It's not just that it's a collection, like a current example models directory. It's a collection, but for anyone wanting to use them, they have to write their own scripts, how to access them, and there are also a lot of like dead models that don't run anymore with current Stan or are against the best practices. And so I think that very important part is this framework. And so we have both R and Python support for that framework supporting. And then it's another issue, that's how we populate the database with models. Ryan also had a question about previously in chat that about like what kind of meta information we have about the models and data. So currently we have very brief. So in that way, it's not a database where you could learn everything about the data sets, for example. We have reference where these come from, but you need to follow then those references to learn more about the specific data sets.
All right. Thank you very much, Aki. You can find Aki at the tables after the session is done. Hopefully you'll be able to ask more questions to Aki there.
So, thanks.
Thanks. Next up, we're going to invite Sebastian Weber up to stage. Sebastian is one of the developers and has really pushed Stan's parallel capabilities. And he's going to be talking to us about scaling Stan's performance with reduced sum in practice. Hey, Sebastian. Do you want to quickly summarize your talk for those that might have missed it?
I hope you have not missed it. Okay, yeah, sure. So in all honesty, I was pretty excited and happy to have reduced sum this year in Stan. And I've seen users on the forum, happily seen it, picking reduce sum up, and I've seen certain problems repeating. And this talk I gave is basically to give everyone a cooking recipe of how to apply reduce sum. So for everyone else, reduce sum allows you to enable within-chain parallelization, and essentially what we are doing is we are recognizing that log likelihoods of our models is typically a sum of independent terms, and these sums can be formed in any order. And this basically we leverage. So the user will have to provide a function which calculates partial sums, and these partial sums will then be calculated not anymore under your control, but basically what your computer is fastest at computing given how many resources you give it. And in my talk, basically you will learn what you can actually expect, because it can be sometimes be disappointing, but there are reasons for it. So we cannot do complete magic. And as I said, I mean, the most important thing, I give people a recipe, like how in small steps they can, in a controlled manner, get from a working model, which they assume is correct, to a model which is optimized a lot faster, hopefully, and still correct. And all of the bits and pieces which you need to worry about when you introduce reduce sum, because it's a bit of a different thinking in terms of how you need to see your data and your likelihood. But it's definitely worthwhile doing it. I mean, as I've seen in the COVID-19 example from Imperial College London, their model went from days to a few hours in 20 cores for 20 countries, where we parallelized over the countries. So,
yeah, speaking of these steps, do you have any tricks for setting up a correctness test? Like, do you use RStan or something else?
Actually, it's the appendix of my PDF slides, and these you can download from the abstract. I recommend you to do something which ensures really for you that your model is correct. For many, this means to use RStan. So yes, I do use RStan. I do calculate the log probability density value for one particular data item and one particular parameter realization. And do it often, frequently, and whenever you are not sure, execute it and make sure you're still in line with your reference. And do it in Python if you like Python more, but definitely do it very often.
Thanks. I really appreciate that, because I think people need to hear that that's what they should be doing. We'll take some questions from the Q&A. The first one we have is from Christina. If we would like to fit a model with the same data and objectives using the sum reduce but compare different kernels, would you recommend to follow all the steps that you explained for every kernel?
What is meant by kernel? I'm afraid I'm not following that, but basically reduce sum shouldn't change how you think about your model at all. It should just really not make you change in terms of what you model, how you model, or whatever. It's about how you write down your model, definitely. And I actually also recommend building reduce sum into your model because you gain what I call scalability. So whenever we build models and make them more complex, we maybe fit something hierarchical, which we didn't do before. So we end up having more parameters. So all of a sudden we need more performance. And if the model is written using reduce sum, you can throw CPU cores at it and still get your modeling time not go up the roof. So
there was a clarification, and it meant different equations instead of kernels. And I think the answer is that this isn't meant to compare against different formulations. This is, yeah. All right.
That's actually the other thing which I definitely emphasize is people should first optimize their model for single core. And many models I see which users present are inefficient here and there. And sometimes, of course, it's me knowing the Stan internals. And I try in my talk actually to give people a bit of a rationale of what makes models fast and what makes them slow, like vectorize them, use reductions provided by Stan, and yeah, what's happening roughly behind the scenes.
That'll lead right into Bruno's question. Is there more reading material about efficient automatic differentiation, smaller tape? Are there cases where it's a good idea to use plus equal operator?
I was a bit afraid of going in this direction. Certainly, really, the big things you need to worry about, not the small things. That's really, and the correctness. Actually, first correctness, second speed. That's always the order which you need to worry about. And actually, there's one more step before it. It's your model, and is your model actually answering the right data? But this is certainly far down the line. I mean, definitely you can look into the paper of automatic differentiation on arXiv if you want to go really into the depths, but to regular users, I would definitely recommend following those rules which I gave in my talk, and then you have already covered a lot of ground.
All right. Well, I'll ask one more question, and then we could have you can ask Sebastian more questions at the tables. But there was something that people might have missed, and it was, why do you have to use a normalized log probability distribution function calls in reduce sum?
Okay, so first we have in Stan the tilde notation for probability densities. Then you get the unnormalized version. And but the thing is, to use reduce sum, you have to write a user supplied function effectively, which is the partial sum function. And in those functions, you cannot use the tilde notation. So if you have a model which is now your reference, in order to make it a reference which you can refer to when you go to user, when you write down your model basically in the realm of users' functions, it has to be normalized, use normalized ones. Otherwise, you cannot compare, at least not at the moment. This may change in the future, but at the moment, first go to normalized densities and then start to introduce reduce sum.
Cool. So it's not a mathematical requirement. It's just a computational one. All right.
If in your partial sum function you can write with basically also down the mathematical density in an unnormalized way, you can do that and then have that as a reference. It will give you the same.
Okay. Thank you, Sebastian. There are a bunch of questions here on the side. So if you get a chance later, please go to Sebastian's table after we're done with the session. Thank you.
Sure. Next
up is Steve Bronder, who's going to talk about the state of GPU computation support for Stan. Steve's been working on the GPU work in Stan along with a lot of people, including Rock today, and Steve and Sean Taltz, and welcome, Steve.
Howdy, hey everyone.
First question here. If I were to know one thing about GPUs in Stan, what would that be?
I think the most important thing is that it's real complicated to get to work in Stan correctly because one of our main goals is that we want the GPU stuff to be a thing that users don't have to be concerned with. They just turn a flag and that's it. It'll just go work for them. there's some other weird complications that we have with, like, for instance, in the model block, every iteration of the model block, you have to transfer data back and forth from the GPU to the RAM, and that is like crazy expensive. So we really can only do it for very large problems right now, though we're slowly working on getting this to work for smaller problems through some other weird tricks.
Cool. What are some of the really hard implementation challenges here?
The hardest implementation challenge is just, it's always going to be data transfers, because I think, you know, people kind of, it's very easy to forget when you just have a big box of a computer that, like, your GPU is like a mile away from everything else. And so every time you transfer stuff over, it is this big cost calculation of, like, is it even worth doing it for this particular problem? And so that we really don't want users to worry about that. And so it's this trying to handle a lot of stuff dynamically for users that could be quite difficult in terms of implementation.
Great. Just a reminder for everybody, if you have any questions, please put it in the Q&A. We're monitoring that. So another question is, where do you need more effort? Is there a place where you have a list of open problems to tackle?
Yeah, so for the folks who checked out the end of the talk, right now, me and Today and Ben Bales are working on these things called static matrices, which will just overall make Stan a whole lot faster. But it requires a big rewrite of the way that we do automatic differentiation for matrix algebra. We don't have a specific list of things that are need to be done right now, but it is essentially like every function in reverse mode that takes in a matrix could also utilize these static matrices. And like again in the slide, you can see that we have, like, for just the CPU versions, we have a 4 or 5x speed up relative to how, like, Stan currently does things. And once we add the GPU on top of that, it actually makes our data transfer so much nicer that we can target much smaller problems and use the GPU, and also get, like, way bigger speedups than even the CPU version.
Wait, just to clarify, when you say 4 or 5 times speed up, you're talking about runtime being 20% or 25% of what the runtime actually is.
So yeah, like so the test that I ran, it was just timing wall time, right? So we were doing just an addition and multiplication like you would do for, like, if you were doing like a regular linear regression or like GLM style model. We found that using these static matrices, like the way that you pack in data to send to the CPU and the GPU is so much better that, like, we really do see like a 4x speed up for, like, even moderately sized problem. Like, when I say 4, I mean a magnitude of 4.
Mm-hmm.
It is like a very, like, that's why we've been going so hard on this, is because it is just like a crazy big speed up.
That's really awesome. We have some questions up on the Q&A now. So the first from Sebastian Weber. Does the Stan GPU backend work well on FPGA hardware, the chips which integrate CPU and GPU on a single die? The magic would be here that the memory transfers are avoided.
So with all of the guts that we have set up, in theory, like, it would just take a couple lines of code to change inside of Stan to get it to work on GPUs. But I think what Sebastian also is referencing is, instead of FPGAs, there are integrated GPU chips that Intel has available. That should work quite well with the stuff that we have already. There is one little trick we haven't implemented yet, but are planning to this year, where, like, essentially, like, if your GPU is directly integrated into your CPU, there's no more of that huge mile-wide gap. Now the gap is, like, right here. And we can do some extra tricks to reduce the number of copies we have to make in that sort of situation. But we haven't set that up yet, because it requires actually detecting whether or not you have one of these, like, integrated GPU setups.
Thanks. And we'll take one more question, and then you can find Steve at the tables, and you could bother him about the code of conduct also.
Yeah.
So the second question from Roman is, does matrix operations like Gillespie decomposition, could that be done with the GPU?
Yes. So currently, if you go to mc-stan.org/math, that's where all of the math documentation sits at. And we also have a list of all of the functions that do currently use GPUs and are, like, totally accessible in any Stan program right now. Gillespie is one of them. We have multiplication. We have inversion, matrix inversion, mdivide left try, and a couple other ones like that, which are, like, usually giant bottlenecks. But yeah, so right now you can go do Gillespie decomposition on the GPU, but it is good on the CPU as well. If you turn on the OpenCL stuff and you're doing Gillespie decomposition, you can also target CPUs. But then the GPU stuff is much better when you have like bigger than like an 800 by 800 matrix. The Gillespie you're doing has to be pretty large.
All right, thanks, Steve. Would you like to thank your co-authors? Because I know this was a massive undertaking.
Yes. Oh my gosh, we have so many people who work on this stuff, and it's fantastic. Like, Rock and Today are like some of my favorite people to work with. Today is just an absolute super genius, absolute great guy to work with. Davor and the rest of the gang were originally on our team working on the kernels that we first wrote out of the box, and were just such a huge help. And then Eric is great for just like really making sure that like everyone's on the ball. Like when we like have to like go publish things and get stuff out and like keep the team like managed really well. He does a great job with that. So my contributors my fellow co-authors are like wonderful. I really appreciate their time.
All right, great. Thanks, Steve. For anyone here, please, we welcome people to join the development team. Just reach out. We're all pretty friendly, I think. All right, finally, the last developer talk is Charles Margosian. He's going to be talking about approximate Bayesian inference for Gaussian processes in STAN.
Cool. Hello, everybody.
Hello, Charles.
Hey, Daniel. So basically,
how you doing?
I'm good. Thank you. How are you doing?
Good.
Good.
All right. You want to give us a quick summary?
Yes. Well, basically, I think there are two perspectives. The first one is I have a hierarchical model, and we know that these can generate posterior distributions with difficult geometries. And these geometries make it difficult for MCMC. And so I don't know how well known this is amongst the STAN community, but when you have a hierarchical model, you can marginalize out some of the local parameters, and then you run MCMC on a subset of parameters. And the huge benefit from that is that this subset of parameters will have a well-behaved posterior geometry. The problem is that most of the times we cannot do exact marginalization, even though in some very interesting cases we can. And the idea was to extend, to try and extend this scheme to more distributions by using an approximation. And that's kind of what we presented here. The other perspective on the matter is that, so this idea of using approximate marginalization is not new. You have softwares that do it. So one of the famous one is INLA. But of course, INLA doesn't give you all the features that STAN has, and STAN doesn't give you all the features that INLA does. So can we get the best of both worlds? Right? And this is kind of a step towards combining this. And in fact, we realized that the interplay between STAN's Hamiltonian Monte Carlo algorithm and the embedded Laplace approximation leads to some really cool new features and the opportunity to fit new models, and also motivates some new algorithmic ideas, notably in the realm of automatic differentiation, which I think you're beginning to appreciate the importance of doing differentiation effectively.
Mm-hmm. Thanks for the talk. In the talk, there wasn't an example of prototype STAN code. And for those that haven't read the archive paper, can you quickly explain how you're separating out the sets of parameters phi and the thetas that you're marginalizing out? Like, how did you actually implement that?
Yeah. So, well, let me give you two resources. First of all, now in the program, you can download the notebook as a PDF, and that's an R Markdown file. So it will show you the code. And also, I created a GitHub repository that includes all the code you need to create the notebook yourself. You'll have access to the code. The way we've done it is we have a function that would appear on the right-hand side of target plus equal. So something like this, target plus equal, Laplace, marginal, etc. So that's going to compute the approximate marginal distribution, marginal likelihood. Right? That's all you need to do. Right? So you don't need to change your call to Stan. You don't need, what you're changing is your Stan file. And maybe anticipating a question some people might have, one way of interpreting this is not that we're changing the algorithm, but we're going from an MC algorithm to an approximate algorithm. But we can also think of it as we're using real MCNC, but applying it to an approximate model.
Mm-hmm.
And really what we're beginning to realize with this algorithm, with variational inference, is that approximate models, approximate algorithms are often two sides of the coin.
Yeah, that actually leads me to the next question is, have you compared the results of using an approximate algorithm to the approximate model?
Mm-hmm.
And it just seems like it might be, the approximate model might be well behaved enough where something like a variational estimate might work well.
Right. So ultimately in the so what we want to do is we want to use approximations for parameters, for distributions that we can approximate well. For the more tricky components, we want to use HMC, Hamiltonian Monte Carlo. So that's exactly what we're doing here, right? Now, regarding, what happens if I throw variational inference at it? What happens if I throw another algorithm? So there's literature comparing Laplace approximation to variational inference, right? I would refer you to that. But in the examples we have where the prior is a horseshoe prior, which is a mixture of Cauchy distribution, here it's tricky to try and approximate the whole thing. On the other hand, my local parameters, their prior is normal. Okay, the likelihood itself is somewhat well behaved. Okay, maybe I have a chance with an approximation. So I do think you need both in these examples.
All right, I'll ask you one more question, and then the one last question I had was: do you provide the upper bound of the bias introduced by the approximation? Are you able to even?
Yeah. Yes and no. So for some likelihoods, we are very confident that this bias is very small. And what we mean by that is that it's smaller than the Monte Carlo error. Right? For other likelihoods, there's some literature on it that discusses it, but sometimes what you get is an asymptotic guarantee. Right? And since we're all running our algorithm in finite time, this may or may not be satisfactory for you. Now, there's a question of, for a general likelihood, right? Do I have a guarantee on the bias? So you don't have that. And what we want to develop, where I see the future of this research going, is we want diagnostics. So instead of this is the upper limit on the bias, we want something that screams at you when the bias becomes large, when the approximation may not be reliable, right? In the way of divergent transitions with Hamiltonian Monte Carlo. The candidates we have are things like leave one out cross-validation, simulation-based calibration, etc. Right? But then also, it's a matter of taking these tools that are maybe good for understanding algorithm in a general framework, to making these tools that users can apply systematically to their model. Right? So those are the open directions. But for the likelihoods we present in the paper, we have good theoretical understanding.
Yep. Thank you, Charles. Thanks to all the developers. They'll be at the tables after the session's over. It's time for the plenary. Let's take a quick breath. Thanks again to our sponsors, Metrum Research Group, Jumping Rivers, HoxOM Incorporated, and Generable. I'm excited for this. Our community is about writing complex models that describe the small part of the world that we deal with. We want to quantify uncertainty and make better decisions using this knowledge. It turns out that some people have to do these things beyond our atmosphere. I'm pleased to introduce Dr. Moriba Associate Professor at the Oden Institute for Computational Engineering and Sciences at the University of Texas at Austin. Welcome.
Hey, how's it going?
Good.
So all right, sounds good. So I guess this is where I can go into a share screen mode and that sort of thing. Let's see.
Yeah. It's be at the bottom, or Alt S. All right, you got it.
Cool.
Great. See you.
All right. So anyway, hopefully everybody can see these slides. So we're just gonna go through this, and it's gonna be kind of like a waterboarding experience. So I apologize for that. All right. So satellites. What are these things? Anthropogenic space objects, human-made, resulting from human activities. They provide a variety of services and capabilities that we depend upon, everything from position, navigation, timing, weather warnings, the ability to observe things in different wavelengths that the human eye can't necessarily see, that provide extra and more insightful information. Even for things like agriculture and hydrology, and where is it best to plant things, or even helping with disaster relief in these cases. Education. A lot of people might take this for granted, but there is a significant percentage of the world's population that doesn't have internet connectivity, and there are a few companies right now that are kind of vying for the upper ground, pun intended, with providing global internet services, for instance. Even financial transactions are really, in this day and age, mostly time-stamped with services that are provided by space infrastructure. So the question is, what if some of this stuff disappeared? You woke up and all of a sudden that wasn't there, and without being a seer like Nostradamus, I can tell you that would be a bad day to your ATM and not be able to get cash. To have position, navigation, and timing services severely disrupted or lost altogether, bad things would happen. As it turns out, we have approximately 26,000 anthropogenic space objects that we are tracking roughly on a daily, weekly basis, out of an assumed 500,000 or more. And so we're talking about things ranging in size from specks of paint, millimeter diameter anthropogenic space objects, to the space station. But we can't track things as small as flecks of paint, as well as cell phones and that sort of thing, depending on the orbit. And so, again, just looking at the trackable set, we're interested in the entire population. We can't measure the entire population, so descriptive statistics is a bit out the window. So we have to do inferential statistics. We're interested in the entire population, and we can only measure some individuals. We don't fully understand the sources and scenes of the population. We kind of know what we launch, but once we launch something in space, how does it age? What happens to it afterwards? Is in many parts, a mystery. Believe it or not. Here's a video from Analytical Graphics Incorporated, and hopefully, let's see if we can get this thing to work here. Yeah, for some reason that's not coming through. Anyway, this was supposed to show you. Here we go. All right. So yeah, so this should basically be showing you what the buildup of this anthropogenic space object population looked like from Sputnik back in late 50s all the way to just a few years ago. and the dots are not to scale. So please don't be too concerned. The dots just represent general locations. But it should kind of give you an idea that, you know, we humans are doing what humans do really well, which is pollute and trash stuff. So we're doing a decent job at that. And every once in a while, two of these objects meet. So physics tells us that two objects can't occupy the same space at the same time. And when that happens, not so good things are a consequence. So here's something, this is a simulation, but the collision actually happened between a working satellite, this Iridium satellite, collided with a dead satellite, this Cosmos satellite that belonged to Russia. They met at a common place and a common time, and these things generate, you know, tens of thousands, more than that, pieces of debris that now are hazards to working satellites. And again, if you can't track all the pieces, then these things are like random bullets moving at speeds upwards of 15 times the speed of a bullet. So bullets are really small, but move quickly, have a lot of kinetic energy, and whenever bullets run into stuff, usually bad things happen by design. And so flecks of paint at really high speeds have a lot of kinetic energy, and even a fleck of paint can go all the way through a working satellite. And we can't predict when these things are going to happen. So that's not so good. This astrograph is one of the things I'm going to talk to you about today. It's a project at the University of Texas at Austin that got initially funded by the Federal Aviation Administration to try to crowdsource or multi-source this space traffic monitoring kind of activity. Here's some planned additions to the anthropogenic space object population in the next few years, mostly dominated by SpaceX, OneWeb, which went bankrupt, but apparently some company from India and the UK government have recovered this thing, and they're going to use it. You have Amazon with Project Kuiper, so they're going to be launching a lot of stuff. So out of the 26,000 things that we track, about 3,000 work and everything else is garbage. So about 96% of the trackable anthropogenic space object population serves no purpose, is garbage, and for all intents and purposes is a hazard to things that are working. But we're already talking about doubling or more the trackable set and all operational satellites to provide internet and that sort of thing. This chart should be showing roughly as a function of number of satellites, altitude. These things aren't uniformly distributed on this plot, and so that should be of concern, because wherever there's overlap and groupings, that means that it's a common space that needs to be managed to avoid conflict and avoid hazards and collisions and these sorts of things. So what's the problem? If you didn't kind of understand it yet, we'll go a bit deeper here for you. So what I'm telling you is that near Earth space is like the Wild West. It's a poorly monitored domain of activity, meaning no single entity has ubiquitous eyes on the sky. So usually when that happens, people know that they can get away with stuff and usually do. There's no real estate deeds. So it's pretty much first come, first served in a sense. There's a potential to make lots of money. So there's a new gold rush, a new bonanza for space. Folks like Elon Musk have made access to space cheaper, which I think is awesome. But like the Transcontinental Railroad connecting East and West Coast, right? It means now it's easier access to space, means more people are launching stuff. We don't have a globally agreed upon norms of behavior to manage this finite resource. And I say finite resource because outer space may be infinite, but near Earth space is finite, and where we put satellites is very specific. So we have these orbital highways, depending on the mission of the satellite, we put these things on specific highways, And oh, by the way, when they stop working, they keep on moving. So imagine you're in your car, you're driving down the highway, it runs out of gas. Instead of slowing down because of friction, it just keeps on going at whatever speed you were going. You were going 80 miles an hour, it keeps on moving, except that now there's no drivability and that sort of stuff. So somehow you just get another car on and keep on driving. So imagine on the freeway, you're driving, and at speed, there are these things that are kind of roughly moving in similar directions without drivers. What could go wrong with that? So yeah, there's no space traffic rules per se. Interestingly, we've been looking at things like traditional ecological knowledge. Say, hey, there's a group of people, indigenous people on the planet, that have learned how to live in harmony and strike a balance with life. Can the voices of our ancients teach us a few things? The answer is yeah. Turns out that some tenets of traditional ecological knowledge are to develop factual observations, empirical evidence, to come up with models and ideas of how things interact within a given ecosystem, mechanisms to manage finite resources, which we could translate to registries, databases, that sort of thing. Really looking at how past and current uses of a given environment have been, ethics, norms of behavior, cultural relationships matter. So these are all things that can inform us on how we might be able to achieve space sustainability. Venn diagrams are needed in these sorts of plenaries. So here's the token Venn diagram. We can move on. So there's this thing called space situational awareness, or SSA. And I tell people SSA is ass backwards. But beyond that, it's really the ability to make decisions for stuff in space. So looking at SSA a little bit more closely, we have this dynamic environment in space. We have the sun's doing stuff. We have this thing that we term gravity. It's very dynamic. And in this environment, we're going to put these anthropogenic space objects, and they're going to interact with the environment and behave in a certain way. That is not exactly known what that effect and impact of the environment will be on these anthropogenic space objects. And so there are some hazards that we need to try to understand and try to infer. And even beyond that, I told you that here's this kind of domain that's poorly monitored, lots of money to be made. If you can't see where I'm going with that yet, here's another way to say it. There is no domain of human activity that has been absent malicious behavior. None. So to think that space is going to be a big kumbaya, we're all just going to like hug and love each other and have pillow fights and tickles, is naive at best. People have done things to each other maliciously, and that'll only get worse. So what's the body of evidence required to assess and quantify those things? How do you measure intent? Because really that's what we're talking about. The difference between doing some activity that might harm somebody unintentionally versus purposefully trying to do that. It's a big deal. So what should SSA provide? It should make space more transparent. So these are the things, measurable things we need to be able to achieve. Increased transparency in space. I know where everything is, who it belongs to, what it could do, potentially. Increased predictability in space. What's going to happen with this domain, with this population that I can only infer statistically? What can I predict over the next few hours, days, months, years? Things that are controlled by people. How do I predict those things are going to move? I mean, it's not just physics. There's cultural competency that needs to be brought to the table. If satellite A and B are going to come within 100 feet of each other 3 days from now, that's a close proximity, let's call it, right? It's physically close. But if satellite A and B are owned by countries or companies that are geopolitically close, like, I don't know, the US and Canada, they might just high-five each other, right? 3 days from now. But if there's going to be physical proximity, but large geopolitical distance, I don't know, dare I say US, Russia, or US, China, or something like that, I'm guessing it's probably less of a high five type of event. So what I'm trying to tell you is that predicting what any given actor is going to do in a common situation requires cultural competency, and that has yet to be applied in the predicting what this population of anthropogenic space objects could do. Essential ingredients for success. Well, you know, I travel the world to talk to many people about this. People seem to be clamoring for an independent way to assess and quantify behavior. Evidence is strongest when it can be independently corroborated, and weakest when it's just like, oh, here's the trust me, trust me card kind of thing. We need to develop some sustainability metrics, working with the World Economic Forum to develop something called a space sustainability rating, for instance, to try to incentivize sustainable behavior in space. Can we develop some best practices, standards? People don't like the word best practices if they're not included in the dialogue of what best is going to be. So we have a few challenges. For one, you know, there's this guy, John Boyd, he came up with this kind of information fusion, data fusion kind of model. We call it the OODA loop for observe, orient, decide, and act. And these are just functional things that we need to be able to do in order to make sure that we can achieve this, you know, space sustainability, safety, and security, right? Gather observations and opinions by themselves don't mean much unless they can be oriented and mapped in a way that is actually usable, that's shareable, that's curated, which I'll get to in a little bit. And, you know, you want to provide that curated and modeled data and information available to a large group of people so that they can all apply their own inference, maybe even compare notes, see if there's consensus that can be reached, right? To then go from that to decisions, and then from these decisions, figure out what courses of action might be. This is just astrodynamics 101, astrodynamics, science that studies motion of objects in space. So we got this thing called the Earth. Again, it has this, it bends space-time. So we feel this thing that's called gravity, but we do that, you know, that from the moon, from the sun as well. Sun has all this energy in terms of photons that interact with different surfaces of these anthropogenic space objects, which causes perturbations in their accelerations. Some of these photons are absorbed and then re-emitted thermally, so that also causes accelerations. The Earth re-radiates heat as well and reflects photons. That also causes accelerations. The antenna transmissions, depending on how much power, Newton's third law kind of thing, also can cause accelerations due to antenna recoil. So these are all things that we need to take into account. And there's this thing called the tides, and relativistic effects and the effects of masses, other masses in the solar system, and that sort of thing. And yeah, the Earth isn't flat. And if you think that, if you're a flat earther, I was going to say, talk to me later. I really don't want you to contact me. All right. So we have the space environment has effects and impacts on objects, working objects, and dead objects in space. We don't fully understand that. I told you that we needed to separate conflict. We need to try to avoid conflict in space. These highways are becoming more and more congested with traffic. Things happen, anomalies occur. And so the question is, was this an act of God, or was this an act of Jimmy who, you know, schwacked me when I wasn't looking? It's very important to be able to answer that question. One of the things that's detrimental to space situational awareness is that oftentimes multiple hypotheses that can be extremely different from each other explain the same body of evidence. That's not good. We don't want a multiple hypothesis, suite to a given event. We want one causal relationships. Eventually, that's what we want. So how do we whittle down hypotheses, eliminate these, to end up with very strong leading hypotheses or one-to-one causal relationships? That's what we're after. We suffer from a lot of confirmation bias, unfortunately, in our field, and we should be allergic to that sort of thing. Once we hold on to a belief, we tend to not want to let go of it. And I'm sure all the Bayesian people in the room, you should agree. And if you don't, then we should have a discussion. You should have a candid talk with yourself if you don't see it this way. How do we know when we have enough information? What happens when we have incomplete information, or when we don't share enough information with each other? Time and time again, I've seen many arguments, who's right, who's wrong, when both are somewhat right, but not absolutely correct. And so there's a need to really gather, collect, assess as many independent sources of information as possible. Okay. Case in point with the space traffic. So if you had to go and see, okay, what does the U.S. government believe, the public opinion about stuff in space kind of looks like this. But here's what the Russian space traffic map looks like. So these things don't look identical. There's some differences. Different sets of sensors, different things being disclosed. That doesn't lend itself well for space safety, security, and sustainability. Even beyond that, here's one object, Flock C10, with 4 opinions. One opinion from the US government, another opinion from the owner of the satellite, another opinion from somebody who has radars tracking the stuff, another opinion from me, given the radar data so that I can apply my own estimation and inference algorithms and that sort of stuff. So, and the difference between these positions are, maybe a couple hundred meters, but that could be the difference between I'm going to collide or I don't collide, move out of the way, don't move out of the way. So which one do you believe? How do we achieve consensus given a variety of opinions and beliefs? Especially when some of those do not have associated measures of uncertainty and can't be easily represented probabilistically. Okay, we have different information categories, which we also need to take into account, and it depends on who provides the information and who's maintaining it. So we have to understand all these different categories in terms of misinformation, disinformation, malinformation, that sort of thing. Again, we can't measure the entire population. Most of these objects, most of these anthropogenic space objects do not report their identity because guess what? They're dead, okay? So it can't say, hey, I'm anthropogenic space object 1, 2, 3, here I am. That doesn't happen. And they're moving at very fast speeds, and we can't physically go to the and mark them. We can't do that. So the question is, how do we do that from sensing, from incomplete data? You can kind of see where I'm going with this. Very difficult, very challenging problem. Detecting is not tracking. Detecting is, as you can imagine, simply that. You have some sensor, some source of information that says, oh, I believe something there. But tracking is saying, oh, I believe there's something there, and I believe that the something there is anthropogenic space object 1, 2, 3. So tracking is detecting and identifying, which is more difficult. And this is just a single night's worth of detections from a telescope called the Space Surveillance Telescope. All the dots are detections. The black dots are detections of things that we believe we know the identity to, and everything else is unknown. So there is a difference between detecting and tracking, and we have an identity crisis in space. Said another way, gather data at different times and places, and these dots in the sky are not self-identifying themselves. So how do you figure out that identity crisis? How do you assign unique labels to these objects? How do you say, that thing that I saw yesterday is the same thing I'm observing right now? Very challenging. We need to start with things that we observe here on the far left, things that we measure, because one thing that I tell my students, they need to recite the mantra. If you want to know something, you have to measure it. If you want to understand it, you have to predict it. And so it's all about measurements. No, you don't measure. So what are the things that we do measure? From that, can we combine these things to gain knowledge on specific parameters? And from that combination of physical characteristics, can we infer functional, operational characteristics? Can we come up with a classification scheme for anthropogenic space objects? We don't have one. We don't have a taxonomy, a scientific taxonomy for these objects. Can we leverage things like schema and ontological frameworks to help us in this endeavor? My argument is yes, we can. We've taken some good steps in that direction already with knowledge graphs. We kind of, we have the semantic description of these different entities, sensors, space environment, the objects themselves. There's three-tiered system on the far right, where we have sources of information, everything from opinions of Jimmy's backyard telescope to the U.S. Department of Defense. These things come in a variety of formats, emails, JSON files, whatever. And then we have to build in from each one of these sources into the mezzanine, the middle layer, which is the knowledge graph database. We happen to Neo4j for astrograph. So we map it into our schema, our nicely semantically labeled schema. And the different apps, which we'll get to later, they don't talk to the bottom level. The penthouse doesn't talk to the ground floor. The penthouse talks to the mezzanine. And that's the power that we want to do. People keep on wanting to talk directly to the raw data. And again, if that's not properly curated and mapped into a lingua franca, then in many cases it's not very usable. And so that's a big deal. And analytics and statistics are greatly facilitated by proper data engineering, modeling, and curation, especially if it's very disparate sources of information. And so then we want to use clustering techniques to do some analysis, be able to discover things that have relationships with each other, which maybe were otherwise, hidden, that we didn't know before, that sort of thing. So in general, our research philosophy for our group, before I get into some examples, are we emphasize abductive inference. I call it the Moriba refrigerator approach, meaning I want to be as prejudice-free as possible. I'm just going to be upfront with that. And from my own experience, I find that data tend to be much more powerful in telling you what something isn't than telling you what something specifically is. And so much like a refrigerator does not cool anything, refrigerators don't cool, by the way, refrigerators remove heat. I want to start with a large mass of entropy, and I want to use data for entropy removal and for ignorance removal. So I want to claim as much ignorance as I need to and allow data to ignorance versus telling me specifically what something is. We want to go beyond correlations to discover causal relationships, like I said. We want to come up with a default action, come up with a null hypothesis, and only reject the null if the evidence makes it look ridiculous. Got that line from Kazi Korzakov from Google. She's their chief decision intelligence person, and I love her videos. So kudos to Cassie for that. I want to avoid making assumptions that go beyond the information that I have in my hand. So I call that line of sight inference. Allergic to confirmation bias. I want to represent uncertainty in terms of things that are actually random, so aleatory, and things that are not, epistemic. And in my line of work, there's not a whole lot of randomness, even though we try to represent everything probabilistically. And by and large, most inference in space domain awareness is Bayesian. We take, or trying to take, this frequentist Bayesian mix hybrid approach. Again, evidence is best when it can be independently corroborated, and multi-source, multimodal sensing is what we're after. yeah, so to that point, frequencies and Bayesianists, what is a belief? How can it be represented? Your interpretation matters. What you believe a probability is matters. For the frequencies, it tends to be, right, the repeatability of an outcome, the frequency of an outcome given lots and lots of trials, whereas to the Bayesianist, it tends to just be the degree to which or not I believe in some given hypothesis. But it's a philosophical difference, but it can matter depending on the types of decisions that you want to make. Default actions versus just modifying beliefs. We like to look at all these types of inference, but we favor abductive for our work. I like to be as prejudice-free as possible. Uninformative priors, does that really exist? I talk to people about these, and people are, oh yeah, I'm going to invoke max entropy. And when somebody tells me that max entropy means a uniform PDF, I call BS. Because if you say the PDF is uniform, you're making a very exact statement that the uncertainty is random and adheres to a uniform distribution, that anything probabilistically is equally likely. That is an informed thing that you're saying. So that's not ignorance. Sorry. All right, so here's some examples really quick before we wrap things up. So you can see this knowledge graph database in Neo4j that has these ontologies, these schema. There are many different users that have come to us with needs about stuff in space. And this introduces a lot of complexity. So here's some examples. One, for people who don't know, Elon Musk is launching a bunch of satellites called Starlinks, supposed to provide global internet. There are a group of humans that are very upset at the existence of these satellites because, they're astronomers and they like to have very dark skies. And when they have large glass to collect lots of photons to see things that are very distant, light years away, that sort of thing, when you have an anthropogenic space object that is very bright relative to the dim thing, then it becomes light pollution. So astronomers are not extremely happy, and so they've come to us asking us, hey, can your knowledge graph database represent the distribution of these objects and help us predict when these things might be coming overhead so that we can understand and plan when best to collect our observations, right? And so this is an example, a video that we've made, our group has made, that kind of gives you an example over a night. This is the entire population of tracked objects, like 18,000 of these things, from twilight, from dusk to dawn. And you can see these things zooming by in different kind of representations. The one on the left is basically a polar plot, like you're sitting at the site. You can, and the right in the middle is straight up, straight above you, so you can see azimuth elevation kind of stuff. The one on the upper right is just where these objects are on the celestial sphere, the look angles from the site to the sky. And then the bottom right is what the telescope could actually see, given that there's something called the horizon and the Earth isn't perfectly flat kind of stuff. So yeah, in terms of visual magnitude, there's traffic. This is showing you there are a bunch of objects that are zipping by. These are all human-made stuff that astronomers need to figure out how to sift through so that they can see things that aren't human-made to get science out of it. So it's a big deal. I talked a little bit about this, Bayesian, frequentist, uncertainty representation. So I'll skip this a little bit, but this is just to say that we're having difficulty really being able to embrace using probabilities in general for just any type of uncertainty. Can you ascribe a probability to human opinion? I would say that's probably not the right way to do it. We need to quantify, monitor, and assess space activities. So from a policy perspective, you can't enforce a law that you can't measure. So it's back to that. Can we monitor how people are behaving? So one example is how to dispose of satellites in this region called GEO. And so we wanted to see, could we use astrograph for this? And the answer is yes. You know, we came up with some questions. We have a way to query the knowledge graph database in Neo4j. On the right, you can kind of see some of the schema that we use for this. And then at the bottom is just you know, some websites where you can actually go and you can run the query yourself and see, you know, 500 non-compliant anthropogenic space objects, or compliant ones, or just in the, you know, in 2019, how many, that sort of stuff. So this has an effect not just for science but for policy and laws itself. So going from something that's like policy oriented to something more scientific, like I said, these objects are not self-reporting their identity. So can we come up with some sort of biometrically inspired space object recognition system? And again, trying to interpret photons that interact with different surfaces from the satellites. We have a photon counter, counts individual photons, which, you know, can only have come from a specific part of an object up there that's moving and it's tumbling. And so here's an example with real data from TOPEX. And this is just giving you an idea of the intensity, the number of photons that we were able to collect as a function of time. And this thing is dead, so it's tumbling. So this gives you an idea, kind of the collected, observed, you know, photon flux for this object. And one of the things that we do is we take this observed photon flux, we unpack the photons to try to understand the inertial to body orientation of these objects. And once we can do that, then we can fix the body frame and say, where in the body frame did photons leave, scatter from, and assume a unit sphere around that, build a heat map on the unit sphere, unpack that into a 2D representation called a Mulvide projection, and try to use the Mulvides as fingerprints. So this is from real data from TOPEX. You can see the band of the part of TOPEX that we were able to observe. The parts that aren't filled out are parts that we weren't able to observe with a single site. But the cool thing is that over 2 different nights, these were the pseudo fingerprints for TOPEX that we collected. And they don't look identical, but they do look very similar. There's some persistent traits, which gives us a warm, fuzzy feeling that at least for some subset of anthropogenic space objects, we should be able to develop an equivalent fingerprint and maybe remotely register, you know, go through an enrollment verification and recognition process with these objects, which could be pretty cool. Unsolved challenges. Look, you know, knowledge graphs are still in their infancy, especially applied to what I just said. How do we represent different types of uncertainty? Uncertainty coming from a sensor that you can characterize its randomness and systematic, you know, biases and that sort of stuff, versus somebody just sends you an email, says, hey, I watched this bright light from my window last night, generally moving in this direction at this time. That's information. That could be telling you about a launch that nobody reported, you know, in the thick of night. How do you represent that uncertainty in what Jimmy said in the phone call? By the way, I use Jimmy a lot for my examples. I don't know. I don't have an evil person named Jimmy in my life. It's just kind of random, except now it's been very systematic. Anyway, moving on. So how do we represent random and uncertain variables? How do we do multi-level security, information protection? What happens when we have conflicting evidence? How do we achieve consensus when we have all these different opinions about something common? Natural language queries, that is really ideal, but it's very difficult to do that. Which ontologies make sense? We try to use a pay-as-you-go ontology development, so not just coming up with semantic, jibber jabber, but trying to use cases to help us drive the development for that. And how do we uniquely identify objects in space? All difficult things. And one of the quotes that I love from Rudolf Emil Kalman, for those who don't know who that person is, that's beyond the scope of this presentation. But one of the cool quotes when he received this Kyoto Prize, in his statement, one of his quotes was, "Whenever a model is built, it's always proper to ponder the basic scientific question, is the model really based on the data? Or is an artifact displaying the prejudices of its creator. And I have to say, having been kind of brought up in my own career, mostly founded upon Bayesian inference than not, that is something that I've always pondered myself. And my ultimate quest is in looking for prejudice-free inference. Can I actually, is that an achievable thing? Maybe not, but that's a direction that we're headed into for a variety of reasons. So with that, I will stop sharing, and there you go.
Thank you very much. That was fascinating. For everyone here, please feel free to use the Q&A session. But to get it started, one moment, let me put this. You know, something technical. You know, we're a technical conference here. How are these space objects tracked? You know, who works on the computational aspects of this? When people are tracking these, are they sticking to laws of motion, or have they tried things like deep learning, or are they just like throwing everything at the wall?
Yeah, so you know, some people are trying to throw in the whole deep learning kind of stuff. You know, just the blind. I have a bag of tricks, and I'm just going to throw my bag of tricks at it. I think that's extremely stupid. And the thing is, yeah, because the thing is, it's kind of the people who like try to train algorithms to find cats in pictures, and you know, some people from like I think MIT said, hey, you know, if you constrain it to what cats kind of look like, it helps a lot. You know, donuts and stuff like that. So the thing is, the physics matters, and so you should inform your algorithms, your learning algorithms, inform them with physics. Maybe you should allow for the hypothesis that you don't know all the physics exactly, but some things you kind of know. This thing called gravity, you know, that Newton kind of came up with and Einstein refined, that's kind of a thing that's demonstrable. Like, start there. So when I said prejudice-free, I didn't mean just assume that you know absolutely nothing. You got to know something. And in terms of the tracking, it's really like radars and telescopes. Those are the two types of sensors that are used. But, you know, what detections are real versus anomalous versus, you know, then that becomes more difficult. And the probability of detection isn't one. So many things affect your ability to detect an object and all these things. So yeah, it's pretty complicated.
Where are people working on these computational aspects of tracking these things? Is there some place where the STAN community could help if they were interested in it?
So I'm gonna say this. Not many people have been focused on the computational aspects, but one of the reasons I'm talking to you is because I lead a group called Computational Astronautical Sciences and Technologies, or the CAST, at the Oden Institute for Computational Engineering Sciences at UT Austin. I have this stuff, you know, the Neo4j, all this stuff is sitting at the Texas Advanced Computing Center. I would greatly welcome anyone from the STAN community to join our cause and show us what STAN could do to make a positive impact on our ability to make space more transparent, predictable, and hold people accountable for how they're behaving. Absolutely.
I have one more question before we jump into Q&A that people are asking. If we're able to track things better, would this affect space situational awareness? And like, would we be able to get around some of the cultural problems if we had better information?
Yeah, so I think if we had better information, we could alleviate some misconceptions. There are several people that have been saber rattling lately, and a lot of, oh, you know, this country is up to no good, and these people did this, and it's like, but it's a he said, she said kind of thing. If we had a pool of data that was globally accessible, I think that could serve as a deterrent and could say, you know what, you're trying to say that country X is trying to like do all this nefarious stuff, but turns out that you have like a gazillion sensors and country X only has like one telescope, and actually they're controlling their object the best that they can. So what seems to you as erratic behavior is the fact that they just don't have enough information to do as good as you do in being able to maneuver or whatever, you know? So it's like, these are things that people should take into account if the information was there.
Great. We'll ask the questions on the Q&A. So one is from, doesn't have a name, but really interesting talk. Do you think prejudice-free inference is compatible with using informative prior distributions that inevitably will vary from person to person?
So I'm trying to realize what that might mean. So here's the thing, right? It's like, I see two ways to prejudice-free. One is you make no assumptions whatsoever, or two, you assume everything possible. So both of those are prejudice-free, right? Assuming everything possible or not assuming anything whatsoever. I struggle with both of those, you know, coming at it from both of those areas. And I would say the easiest thing to do is probably try to assume everything possible. But as you probably know from people that engage in multiple hypothesis testing, sometimes given the evidence, it's very difficult. You know, many hypotheses can survive because you don't have uniqueness. When you don't have uniqueness, then there's ambiguity, and the ambiguity is real. So it's informative at that point, right? It's telling you, hey, you don't have enough information to really disambiguate between these things.
Another question from the audience, from Raul Lozada. Is there a known way to remove dangerous particles from space?
So Surrey Satellite Systems developed a harpoon and a net that they tested on orbit like last year. So it's like fishing techniques on orbit. Astroscale is a company out of Japan that's developing what they're calling orbital sweepers for smaller objects in low Earth orbit. The European Space Agency is funding ClearSpace to go and remove a piece of debris, a Vespa payload adapter, in 2025, led by Muriel Richards out of EPFL in Lausanne in Switzerland. So people are looking at this. The biggest issue with the growth of these objects in space is a lack of compliance with agreed upon guidelines. So most people just aren't complying with these guidelines on, hey, if you did these things, you would help not create more junk, and people aren't doing that. And so the degree of non-compliance is the main culprit at this point.
Got it. Simon, do you want to jump on real quick? Oh, Simon was there, and then there he is.
Hello, Alan.
Hey, Simon.
Yeah. Sorry, I've taken my shirt off. It's too hot in the UK. So my question was around where on earth do we start modeling the politics? So I can look at physics. I can figure out how to model the fact that the Earth isn't a sphere. I can figure out what the gravity from Jupiter is. I can work out antenna thrust. I can do all these things because it's math, right? So that's kind of easy. Where do you start modeling the political impact of different nations? And I don't know where to start, let alone where to finish.
Yeah, so I'll put it this way. One of the things that I've had one of my students in Australia looking at is there any cultural signature, for instance, to how people register objects in space? So there's like a United Nations Convention on Space Object Registry from the 70s, and all the information on the website is from like faxes and stuff onto like PDFs and these sort of things. And so PDF meaning like the document, not probability density functions. And I have to understand the crowd I'm talking to here. And so it's like, so we've built these like web scrapers that have gone into these documents to pull this stuff. And it turns out, based on the behavior, the observed historical behavior of objects registered, you can tell which countries made the registration without actually having the label at some point. It's like China always registers a couple hundred things at a time. The language says register these things as soon as is practicable. Some countries interpret that 3 years after the stuff has been launched, which isn't very useful. So I think in looking at how people have behaved, putting that in context to historically, what have they done in specific situations. What we really need to do, Simon, is, this is, to me, it's the biggest challenge. We need to develop a computational social scientist. That is the challenge, is I can represent an astrodynamicist computationally. Like you said, it's physics, it's this, is that. How do I represent a social scientist and an anthropologist computationally? That's the challenge.
You said that the data, at least in one cut of it, you can see that if you did the analysis that you've evidently done, that there is a correlation to the political landscape that you can pull out.
Yeah. And in fact, I would even say this, right? Even with the United States, if you look at the objects that have been launched, put into orbit, and how these things have been moved between a Democrat and a Republican administration, you might even see differences there, because they tend to approach the role of space in different ways. So even geopolitically, the same country going through different kind of political party kind of stuff, you can probably, with enough data, you can probably see and infer trade winds.
Thank you.
There's a question that was asked, and I know the answer to this. Can you share a GitHub repo of some of the Stan models you tried? And I'm guessing that's a no, because I'm assuming you didn't use Stan.
I didn't use Stan, but yeah, if you basically Google ASTRIA and GitHub, you'll find our GitHub repo.
Great. Would you mind posting that into the chat at some point?
Yeah.
For the audience, Simon, who was just on here, has actually used Stan for astrodynamics problems. So if you have questions, you can ask him about some of that stuff. Let's see, some of the other questions here from Akisato Suzuki. As for the last quote, wouldn't it be risky to trust data too much, e.g. because of measurement errors or random variability? Shouldn't expert knowledge via informative priors help us hit a balance?
So I think, look, if you actually have information at hand, I think you should use it if you can actually trust it, right? And so one of the things that I've seen in my own field is that people will characterize a sensor today, and then whatever those characteristics are, they'll assume that for the next 20 years. That's where I think that, so the thing is, we should be in the trust but verify kind of thing. And whenever we have knowledge, we should always subject that to new evidence so that we can allow our beliefs to change as they need to. So I guess that's what I'm more cautioning on.
Yep. Have you looked at the value of information analysis, sometimes called multi-stage or pre-posterior decision-making, to understand what precision bias, and I don't know what POD is, but is needed from your sensors?
No, I have not. All I've done at most is use things like, covariance studies, Fisher information analysis, that sort of stuff. I've done that. And of course, Monte Carlos and that sort of stuff, but not what they specifically suggested. So that's great.
Great. Those were all the questions on the Q&A at this point. Does anyone else have anything? Oh, thank you for posting the GitHub link.
Yeah, I saw somebody, Jonah, did that as well, so thank you.
Yeah, so there's one more. From Amelia Vargas, would love to hear more of your thoughts on what it will take for us to develop, in quotes, computational social scientists.
I have ideas, and yes, that would be a lengthier conversation for sure. But yes, I have ideas, and I'm starting to go down that path.
Great. Thank you very much for your time. Hopefully you'll be back for some of the networking session. Yep.
Absolutely.
Thank you.
Thank you, and thanks to Simon for inviting me as well.
Thanks, Simon. Thanks, Moriba. All right. That was really interesting. Next up, we have, let me look at the schedule. Next up, we have the 6 1-minute pitches again. So we'll be reminded of what the talks were before we get into those discussions. Hello. It's 2:02. We're scheduled to have the next discussions happen at 2:06. Why don't we take a couple seconds, like 30 seconds, to take a stretch? It's been, I don't know about you, but I've been sitting in this chair for a long time. While we're doing that, I can thank the sponsors once again. We have 4 sponsors this StanCon. We have, let's see, Metrum Research Group, Jumping Rivers, Hoxo M Incorporated, and Generable. Thank you again to Sally and Kinetics. They've helped make this event really seamless. All right. Without further ado, Wade, are you around?
Yeah.
Hey, Wade. Good to meet you.
Hey, Daniel.
So Wade's talk was on using Stan for spatial smoothing and regression parameters. First off, thank you for your talk. Are you on Discourse, and how can people reach you to talk about the model?
Oh, probably the best way to contact me is still email. I know how to use Zoom, and I'd actually never heard of Discourse, but I guess maybe I need to learn about it.
Aha. Discourse is the Stan forums where you could, there are a lot of people there. I know people still aren't aware of it, but that's where we have a lot of discussion there. All right. For anyone on the chat, please use the Q&A to ask questions. My first real question, 31 days to run. Wow, I'm sure lots of people are wondering, how do you have the patience to run it for that long? Are you used to running things for that long?
Well, we're in COVID, so I'm working from home. I got my office computer that's just sitting there doing nothing. So I'm not supposed to go in, but I just went ahead and started it up and let it run. Now we had a thunderstorm or two, so it stopped a couple times. I had to go restart it. But yeah, I've had things run 2 weeks before, but this is a little longer.
Wow. When you said that one run takes a few hours, what does that mean?
Well, actually, I didn't get that quite right. It's really a few days, but we're doing what's called rolling regressions. And so every time we add a new year, because we're doing out of sample prediction, every time we do add a new year, we're doing a new estimation. And so there's a loop that it goes through. And so you do 20 years, you can see it's going to take a little over a day to do one of them.
Interesting. Can you walk through how the results of this sort of model informs crop insurance premiums?
Okay. Well, when you're pricing insurance, what you care is about the tail of the distribution. You're just calculating an expected value of the value of being below some threshold. And so all you need to do is get the distribution, and that's what we're doing here. The key parameter in pricing insurance is actually the location parameter. And so that's what we're worrying about most here, even though we do worry about the variance too.
Interesting. And our crop insurance, are the premiums handled on a zip code boundary?
This is a special type of index insurance, which uses county yields. And so this particular type of insurance is based on county yield averages. There's other types that are based actually on fields, the history of fields. And we certainly are not able to handle that many observations.
Interesting. We have a question in the Q&A from Soyeon Cha. Hi, Wade. In constructing correlation matrix, did you compute the distance between two counties for all cases, or just consider nearby regions? If not, what about considering only neighboring regions?
Okay, we do it for all counties. And what we find is that when we're talking about a state, that even the most distant counties we have in our data set, the correlation's still fairly high. And so I know some people do spatial stuff where they end up with sparse matrices, but in our case, we've got correlation all the way out. And so it doesn't seem that promising to go that way.
And another question from Jonah Gabry. How common is Bayesian inference in agricultural economics? Are there things we can do to bring more awareness to STAN, and how can it be useful to others in your field?
It's not way common. You know, I know 3 or 4 other people in ag economists that are using STAN, but they're using it mostly as a gimmick. You know, they're doing something that you could have done with frequentist or just any standard Bayesian package. So it's not way common, but there's some.
And a question from Roman. Are you considering your data as a real or point observations?
Okay.
I don't know that term.
Well, I know what he's saying.
Okay.
And, we are doing it as points. And so we're using the county centers in calculating distance. And I don't know how we could do it otherwise, unless we use CompuCurator. And that's not what we're doing.
Got it. Yeah, I mean that's an interesting observation that Roman made, because it's a modeling assumption, right? That particular one, and how you collect your data. So another question for me is, when you say you couldn't do something with Markov chain Monte Carlo, what were you using before?
Well, it was let's see, Metropolis Hastings within a give sampler, because you told me I used the wrong name. So thanks, I learned something. And so it's in R, like this is R STAN I'm using, so it's written in R, and it uses a pretty decent, guess at the distribution, but it is one that my student wrote himself, and it just choked on, I guess you don't really invert the matrix, but the equivalent to inverting the matrix, and it just was too slow.
Mm-hmm.
And we couldn't get convergence. Or actually, we got 27% of the counties converged.
So before using something like STAN, were you using SAS? Is that used a lot in your field?
Well, certainly SAS is what I know, without a doubt. But the SAS, has some built-in Bayesian stuff, and I've tried it, but it's not flexible enough to do something like this. So what we had before was this R stuff, and it was very specific to this, written specifically for this problem. We started doing Pareto tail distributions. I don't know, there's an old JASA article that we kind of followed, but we couldn't include time trends there, and so that's what we're trying to do here.
Mm-hmm. Another question from the audience here, from Tyler Mangan. I understand you didn't need to include prior information in this application, but do you ever find priors useful in expressing expectations from economic theory?
Yes, very much so, but not in this problem. So in some other research I have that I'm working on, estimating elasticities for livestock, like for the EC, say you have some theories that you have homogeneity that you impose, and in that case, actually, we've taken, like, say that EC has their own priors in their current model, and then we brought the data in and combined those together. So yes, we have those, and that's a very different problem. And I'm still working on that, but yes, very much so.
Great. Well, thank you for joining us. Wade will be at the tables after this session, and you can find him and ask him more questions. Thank you very much for your work, and welcome to the STAN community.
All right, thank you.
All right. Up next is Sean Pinkney. Hey, Sean.
Almost.
Cool. The talk title was Multivariate Synthetic Control to Estimate Missing Data in Hierarchically Correlated Series. Did you ever read that off in your own talk, or am I the first one to read that?
Maybe at the beginning, I don't remember. I didn't even, I think, watch my video after, because, I don't know, it's embarrassing to watch yourself.
Yeah. Yeah,
but,
cool. So,
oh yeah, go ahead.
Yeah, my first question was like, the first reaction I had to this was rad, like building a quadratic optimizer embedded inside a STAN program. What made you think of including a quadratic optimizer?
So I think, I'm standing on the shoulder of all these other guys, women, who've done synthetic control stuff in the past. So I'd say probably like Abadi at MIT. So he has a bunch of papers. He was probably, I think, one of the first to really formalize this notion, and that's directly from his first papers on that stuff. Now, we tested out without doing the quadratic solver, and we found we can get close. It does get, you can use a simplex and estimate it, but what was with the quadratic solver is that we don't have to worry about that parameter being estimated really. And the key there is that what we wanted to be able to jointly put in correlations from these other series. So you can think of, we have these nested time series. In this case, we have a bunch of countries, and those countries each have in this case, they had 2 time series, but we could have many more. And one of the 2 series was missing in some subset of those countries. And then it was like, hey, out of all of the series that we know and correlations across them, can we use that correlation structure basically to get an estimate of those weights in order to get this estimate of the synthetic control?
Cool. Is the quadratic optimization problem, is it easy to set up so that it's convex? Was it guaranteed?
It's not guaranteed. So I think in our case, I think our specific problem that I show here, that we had no problems with this, because basically the way that we've solved, I guess, the convexity issue is, first off, our series are relatively stationary. There's not too much trending going on, and if there is, it's only a couple countries. And then the other piece is that we normalize all the series to zero, zero mean, 1 standard deviation, z-score standardized. So they all lie across each other. Now, if it is the case though that you could have all the series which are greater than, and if the weights are constrained to be between 0 and 1, there's no way that you can weight a set of groups that are all higher to one that is lower. And So obviously they lie outside the convex hull, but that ended up not being the case for us. So I guess that's an open question for the series, but we didn't have that issue.
Great. So a question from the audience, from Bonnie Harvey. For Sean, you had mentioned that we don't need estimates for delta in the latent factor model. Does this mean you assume fixed monthly effects across all countries? What about seasonal differences?
So there's kind of two questions here. The first one is, yeah, if you look at the talk, there's this delta fixed time effect, but those will vary across the hierarchically, like basically related, or the nested time series. So they vary in that case, but I think they'll be the same, yeah, for all the countries. Now, the way that we get around that other piece for the seasonality and stuff is the latent factors will vary for each of the countries, and so those should capture. The idea is that it's a latent factor model, and those vary by time. And then country, and so those should capture that that seasonality and these like idiosyncratic, I guess, but country effects.
Thank you. Another question from the audience, from Christina Barber Alvarez Bulia. What would be a good known/unknown data ratio in this kind of model?
Yeah, so I think it's always the case that the fewer unknowns that you have, the better. But I think the interesting piece there is that, yeah, this model it can't handle. I think when you have more unknown pieces than known, it's not gonna work that well. So even in, I guess, if you go back in the synthetic control literature, you need to have like a candidate set to weight from, and that set can't be too small, otherwise there's no optimal weighting. But also there's problems when it gets too big. We kind of had that Goldilocks zone where we only had like 15 candidates, and so it was a good set to pull from. There is stuff in the literature about when you have a huge set of candidates, how to do kind of like they call like a sparse piece, but I'll let you kind of look through that. I think Abadi has some papers on
that. Just a question for me. Have you run this with full MCMC, and were the results similar? And how long did it take to run using, ADVI?
So we never did. We did it originally, and as the model got more and more complex, so we start from simple.
Mm-hmm.
And then we checked everything, and originally we wanted to do this with HMC, and we were kind of staying in there, but as we were putting pieces in, and it kept getting more and more complex, and we had to run this, so we didn't build the model such that we put in, so we had age, gender, and then website, and we ran this model for each age, gender, and website. We didn't put all age, genders, and websites together, which you definitely could. Now, even with that smaller subset, it was taking an extremely long time to run. And so we just decided to go with variational inference. And yeah, we know it's not ideal, but I think what we're working with here, we're still working with approximation. So like the series that we're looking at are also projections. So nothing is actually like a truth set at this point. So we're looking for trends, being able to capture trends, being able to capture some of the variation. But specific point estimates, I don't think it matters as much. So basically, in that case, so I think I messed up. What was this? Did I answer that question fully or no?
I think you answered it enough. Let's take two more questions, and then we'll move on to the next speaker. So the first one from Elia McDonald Fayette. Sorry if I missed this, but does your approach provide inference around the synthetic control? Inference is a big issue in applying synthetic controls to causal inference, right?
Right. guess you're, I mean, when you say, I don't know, we'll talk after, I think. So definitely come to my table and we can discuss more. But basically, it could. So there are a few things that we would like to do if we have time to look at some proofs and things. I'm not sure yet about that. We were just mainly concerned with estimating these pieces of missing data. But I think you could theoretically do it. I'm not sure if you would want to, given the nature of some of the variability with it and everything. I think you would. It would be preferable and to have at least one time point to anchor on. And if you have some pre-period things, which would make it more of a traditional synthetic control, but then you could add in this this piece where you have the correlations and everything too, if you have structure like that.
All right, and the last question from Armon. Hi, Sean, you may have mentioned this, but why exactly were the data missing? Do we have any reason to think that the missing is non-random, i.e. synthetic controls may not be representative?
Yeah, so yeah, I guess that's a very interesting thing. I never brought it up. So it is missing for a very specific reason. It's missing because my company, we have pulled out measurement in those countries for various reasons. And so we're actually missing it because it was a business thing where we're missing it. We're not missing it because of some other external factor. Like, we know exactly why it's missing. So that's at least taken care of there.
All right, thank you, Sean. You can find Sean at the tables. Martin, are you on? And Armin, you might as well jump on too. Thank you for taking over, Martin.
Yeah, going so far.
Hi.
Okay, great. So we have Armin, and I'm not sure I know how to remove the old question, but that's probably going to work okay. Okay, so please ask questions for Armin and causal inference. And if you don't know if you should ask, then you can ask questions anonymously. So please do ask questions. We'll be super happy. So since we don't, no one pasted something yet, so I'll start with one question of my own. So in the papers I read, most people interpret directly coefficients on their effects variables, basically directly the effect, and don't try to estimate this causal odds ratio that you did. So do you have some thoughts on like what use cases are better suited to just looking at the effect, and where it's super important to include the distribution of the confounders and compute the way you did in the presentation?
Yeah. I mean, I think this is a great question. I actually had a whole Twitter exchange with Alex Hayes and Joe Hogan about this issue of like, okay, so a lot of people just estimate that treatment dummy, they adjust for a bunch of things, and they look at that treatment dummy coefficient, and then they interpret this as a causal effect. And actually, that's what I would call a conditional effect, whereas like in the presentation, I was talking about this marginal effect, which is like what would have happened on average if everyone in the population that you're trying to make inference about had taken treatment 1 versus treatment 0. And I think that in some simple models, these are actually the same thing. So like for a linear model with just the treatment dummy, that conditional effect is the marginal effect that I'm talking about. And so most people continue to interpret that coefficient similarly in other nonlinear settings. But it's actually not, in general, these are actually two different effects. So that dummy is telling you the treatment effect conditional on a certain set of covariates, right? So if I condition on all these different factors X, in that subset, what is my treatment effect? But that's very different from what is my effect overall, right? So if I'm saying, okay, here's my treatment effect among males, okay, but if there are very few males and then the effect in females is very different and there are more females in the population, then your marginal effect overall is going to look very different from your conditional effect. But I think in general, if you want a causal interpretation that is marginal, you would need to do this integration or standardization step, sometimes they call it. Is that clear, like the difference between the
would you have like some actual problem or data set you've worked with that where this was like super important and the difference was big?
Yeah, it's interesting. I mean, usually I always target the marginal effect and I don't bother with over-interpreting the conditional effect. So I always, in applied causal papers, I always do the marginal effect. So I've never really compared the two, but there is, like, Jensen's inequality tells us, I think, that the marginal effect is always closer to the null than the conditional effect. And that has to do with whether you're taking the expectation of a function or the function of the expectation. So there is a relationship between the two. And I think the more severe the confounding, the stronger the difference between these two effects would be. Yeah.
Okay, so we have a question from Sarah Van Erp. And so you talk about the importance and difficulties of sensitivity analysis. So what do you believe is the best way to set up the sensitivity analysis, and especially to avoid those sensitivity analysis too easy?
Yeah. So I did mention that there's this trade-off between making the sensitivity analysis interpretable versus making it too trivial. And this is so subject matter specific, and it matters what model you're using and what the violation that you're concerned with is about. So if you're running instrumental variables, you might be concerned about violations against the exclusion restriction, right? If you're running a difference in difference model, you might be worried about parallel trends violations. In general, I think I have a few bits of advice. One is to try to think carefully about the magnitude of the bias that you're considering and whether it's absurdly high. Try to relate it back to things that you know from the subject matter in the literature. So if you know that a huge driver of the treatment effect, for example, is sex, and this results in a relative risk increase of like 6%, right? And that's one of the bigger effects out there. Then when you're exploring violations of, say, unmeasured confounding, do you really want to explore, like, do you really want a prior that says any unmeasured confounding more than 6% increase is reasonable? Because it might not be, right? So you always want to think about the plausible values, and you get that from the literature. Other than that, it's very subject matter expertise. You got to work closely with your collaborators. Like, I'm fortunate enough to work with a lot of great clinicians who know a lot of subject matter expertise about virology and cancer and stuff. So that's where I get most of this from.
Okay, great, thanks. And so we have from Wish, is like, how does the approach you described compare to like what Judy Upperall discusses in his writing, or other like frameworks for causal analysis?
Yeah, so that's a really good question. The way that I view causal inference, and I think this is common in like the Jamie Robbins sort of camp, is more that the statistics and the causal inference are really just separate things. So whether you use the Pearl paradigm or the Robbins paradigm to actually identify your causal estimand, that's where the causality stops. And then once you've identified the estimand, and now you are left with a purely statistical problem of how to do inference on this estimand. Right, so I view this as the modeling and the statistics that you use should be sort of agnostic to what paradigm you're using. That being said, in my experience, at least with the standardization procedure I laid out, you could do standardization using do calculus from Pearl's perspective, or using like the Rubin perspective of potential outcomes. You'll get the same formula in the end. So I think practically speaking, the differences in these paradigms are not that big, although some people on Twitter would disagree with me.
Yeah, that happens. So probably our last question is like one of the methods I'm somewhat more familiar with is multiple level regression with post-stratification. where you have some external measurements of the whole population, and you don't, so you can use this to inform like the distribution of the confounding variables or of all the predictors you have. And so so in which, I guess, like in a lot of medical contexts you were speaking about, so we don't know this, but I guess we sometimes know like the incidence of diabetes, we know like age distribution of various comorbidities and these kind of things. So so does that like somehow, can you do like something in between where you like, you don't have this precise information like census data, but you have some like weight information on these distributions from like whatever sources you have?
Yeah. So I've never done MRP, but like from my basic understanding of this is that, you have this sample that may not be representative of the population. And so you run this multi-level model, and then post hoc, you sort of adjust for it by saying, oh, I undersampled some stratum of the population, but I have data on what those people look like in the population, so I can sort of adjust it to be more comparable. I think actually post-stratification in that sense, in that Gelman-Little sense, is very closely related to standardization, right? And post-stratification, you're standardizing to data from a population that you get from a census survey. And then when I'm doing my integration here, I'm standardizing to the average person in my data set. So they're actually pretty equivalent, I think, in some ways, though I would have to think about it. But this is not at all surprising because, a lot of the causal inference methods come from the survey literature. They come from, things like inverse probability treatment weighting comes directly from these types of survey weighting that correct for non-response bias or correct for undersamplings. And also like, Gelman, who came up with MRP, was advised by Rubin, who also came up with a lot of these causal inference methods. And if you look at a lot of Rubin's early papers, they're heavily motivated by survey sampling methods. So I think these methods are all really, really related. What you said about if you had this external data, could you actually use that somehow? Yes, you can. I'm not sure how, but there's this whole literature in causal inference on transportability, is what it's called. And so if you estimate an effect in using one population, under what assumptions is that then valid for another subset of the population? So under what assumptions can you transport that then to some other subpopulation? So that's the literature that deals with that.
Okay, thanks very much. We're getting some good stuff in the QA, but time is running out. So you'll find Arman at his table after this. So please talk to him, and we'll move on to Matthew. So thank you very much for your time and for your insights.
Thank you, Martin.
Hi.
Hi, Matthew. Nice to see you. So we're moving to a whole different world of visualization, and before people have time to write their questions into this QA window, which please do. My questions are not that great. So I'll start with an open question that interests me. Like, you have a visualization of uncertainty. Now, like, you understand your model, you know what you're doing. You've been working with probability for years. So how do you test that, like, it's comprehensible to other people than you?
Yeah, that's a great question. And there's a lot of different ways that people try to tackle this. And certainly in the uncertainty visualization literature, and I kind of have my own preferences. I mean, there's simple questions you can ask, like, can people read off probabilities from this chart? That, I think, is sort of a baseline for understanding, but it doesn't really tell you if people are going to be able to reason about that visual presentation in an effective way, right? Like, just because someone can read off a probability with low error doesn't mean that they know how to use that probability to make a good decision. So, there are other things that people test. You'll test things like subjective confidence, but I personally I see papers that do that, but I'm not a big fan of it because there's really no objective standard for what subjective confidence should be. And you tend to get these nonlinear relationships between probabilities and people's subjective confidence. And you can't really say, oh, this chart makes you more or less confident. What's the sort of normative standard for that? So one of the things that we tend to use, I've been tending to use lately, is incentivized decision-making studies. So we basically put people into uncertain scenarios, we give them incentives, asking them to bet on different things, and then we can measure, like how much money they make, or what's the expected value, what's the expected payoff of the strategies that they take, and that sort of thing. And I think that tends to give you a better sense of if people are able to make effective decisions with an uncertainty visualization, then just, can they read off a probability, or what's their subjective confidence? There's other things that you can look at. So we also take some approaches from the psychometrics and psychophysics literature, where they'll look at things like just noticeable differences, which is given two different presentations or two different or the difference in the chance of some outcome on two different visualizations, what's the point at which people can actually notice that there is a difference in chance in that outcome? But yeah, so there's kind of a toolbox of things, and it kind of depends on the situation and what you really care about for that task. But I tend to really like these more incentivized decision-making approaches these days.
Yeah, but like if I don't have a research lab and I'm making a call, for my website or for my paper, what can I do, to see if it works?
Yeah, so this is where I think you start getting into some of the sort of things that we know from the literature that have generalized over different visual presentations, and you can't really guarantee that this is going to be true in your particular scenario, but there's some rules of thumb. So that for visualization in general, we know that there are certain encodings that people are better at decoding, right? So like position, we're very good at decoding information from. So one of the things I talk about in my talk is, well, if you care about probabilities, and say you have like a density function, well, to get probability out of a density function, you actually have to read area, not position, right? Because you have to do that integral, and you have to do that with your eyes, and we're actually not that great at it. This is one of the reasons why a CDF, for example, can be a better way of presenting probability information, because you're actually mapping it onto position. There's also things like cognitive uncertainty cognition. So, frequency framing is this idea of, rather than presenting, say, like a bar chart to show a probability, you might show an icon array, which is like, here's a grid of 1,000 outcomes, and I call it.
Okay, yeah, I'm sorry. I just think we're repeating the talk, and there are other.
Yeah.
So thank you very much. So we have Dima asking how could you visually separate the uncertainty, the epistemic uncertainty parameters from uncertainty of variability in from the actual variability in the visualization? So,
yeah, this is a great question that we've just been starting to try to research, and I don't really have great answers to. It's this question of how do you present sort of different levels of uncertainty in the same visualization, right? Like you might have parameter uncertainty, so uncertainty in a mean or a standard deviation. You might have then the combined sort of predictive uncertainty of what that implies about the posterior predictive distribution. You might also have like the Monte Carlo error, right? So how would you even stuff all of those things into a single visualization? I don't think we have a good answer to that question, right? So there are some approaches that people do, like you can do things, Krushki, who's a psychologist who does some Bayesian stuff, has some of these visualizations where he'll show things like, given joint draws from the mean and standard deviation of a predictive distribution, show, say, like 100 draws from those visualized as density plots. So there you're seeing both the variability in the parameters, the mean and the standard deviation, as well as the sort of implied variability in the response variable, right? So it's hard. We don't really have any research telling us if people are able to read charts like that or what they would do with them. But basically you're trying to find different channels. So we talk about visual channels and visualization, like position, area, things like that. You're trying to find different channels that don't interfere with each other too much to communicate both of these types of uncertainty at the same time, and it's very difficult to do that.
Yeah, and so also we have a question from Ravin Kumar, is you mentioned congregation in your talk and use a normal person on the subway as an example. So how do you think there's different abilities in for understanding in industry, academic, general public? Like how do you understand that? Where do you get this information? Like,
yeah, that's a great question. So I mean, there's a couple of different. So I think the answer is yes, but sometimes not as much as we think. I mean, I always kind of joke, you know, when you're talking about uncertainty visualization for lay people, most scientists are lay people in terms of understanding of uncertainty. And so often the presentations you might use for one of those groups, you probably want to use for the other. You can try to measure these things. So there are standardized scales for things like numeracy. There's something called the Berlin numeracy scale. And that one, for example, is basically just a bunch of really dickish questions about conditional probability. And one of the things that you find with that, at least we found when we've included that in studies, is there is a systematic effect of people with lower numeracy do perform worse on sort of the uncertainty visualizations that we try. It doesn't seem like there are uncertainty visualizations that tend to be worse for people who are bad, and like there doesn't seem to be interaction effects there that we've seen, right? So it's not like you get people who are you know, like lay people who are bad at reading one uncertainty visualization but good at another, and experts who have the inverse effect. We haven't seen anything like that, and I don't really see any reason to believe that that would be the case. Usually what happens is if you have a better uncertainty presentation, it doesn't make people worse, but it might make some people better.
Okay. Yeah, and so like probably one last quick question is like, does coloring matter a lot in uncertainty visualization, like grayscale versus full color?
Yes, I mean, so I'm not an expert in color with respect to visualization, but the general answer to that question is yes. Color scales. There are a lot of different color scales. If you want to go and try making your own color scale, I usually tell people don't. People spend entire PhDs developing color scales that are very good at being able to perceive differences that are perceptually uniform, that, you know, people with color blindness, various different types of color blindness, because there are multiple, that work for different people with different types of color blindness. It's also the case that grayscale versus color, so there you'll be able to see, I think, finer differences with well-designed color scales than grayscale. So it's like, it's a very complicated area. It's not really related to uncertainty visualization necessarily, but yeah, I would say in general with color scales, you want to just use something that someone who has spent a lot of time studying that has designed rather than coming up with your own.
Okay, so thank you very much. It would be cool if you could post to the chat like links to some of the research we talked about. That would be super cool. And yeah, thank you very much for your time. You will find Matthew at a table later, so ask him all the other questions. Thanks for the questions. Have a nice day. And yeah, I'll have Jonathan and Shredder.
Hello.
Hi. I guess this is very quick. So I'll try to ask us some simple question and to get us started once again, and hopefully we'll not run that late as before. So, one question is that, like, how big does a model need to be to, like, you know, that I should consider shredding? So, like, I don't want to learn a new R package. Like, it's nice, but maybe I don't want to learn a new R package. So at what size of models or number of models, or like, would you say, like, I should definitely check out Shredder because it's gonna save me a lot of time?
So Shredder kind of splits into two pieces for reducing the size of an object. If you have a relatively small model, just a few parameters and not that many observations or parameters that you need to go through, then Stan, or RStan in this case, it keeps a lot of information inside of the object. So in the post-processing, you're carrying around relatively large object, even if you didn't simulate anything. So there's a function inside of it that has an ability to remove those StanX. So it would reduce roughly 5 times the size of the object just from removing all the cached information, the summary, the Stan model itself that's inside of it. So that's a vignette in the package that you can look at for the comparisons. And then if you have a larger model, my initial model that I was working on was roughly 2 gigabytes post-processing. So the earlier versions of TidyBase, to convert that into something workable for investigating that object took a long time. So I had roughly 14,000 observations, 17 parameters, a hierarchical model. So that kind of thing, if you can pre-select your parameters, it reduces by a lot the amount of space, and also thinning out the posterior samples, the post-warm-up samples. So once you get a higher dimension, then yeah, of course, it's going to reduce the amount of size, and also it helps you target your analysis. Even if you do have a small model, I did benchmarking with TidyBase. When you just use TidyBase to select 2 parameters and do spread for that. And then if you pre-select your parameters using Shredder, reduces roughly 60% of the runtime from microbenching it. So there is a definite reduction in runtime, and it's not going to make your models run faster at all. It's post-processing. Shredder is for post-processing.
Okay, cool. So we have a question from Mike Lawrence. So it seems like Shredder might be useful to both TidyBias and the NetCDF projects. So have you thought about connecting with those and, like more integration using Shredder as like behind the scenes in TidyBase, for example?
So I don't maintain TidyBase or NetCDF, but I do talk regularly with the maintainer, who's a previous speaker right now, about TidyBase and directions it's going. But yeah, that's future projects that obviously would be happy to discuss implementing that.
Okay, like a similar question from Josh Duncan is like, is there like some connection with the posterior R package or CMP Stan that for Shredder?
No, not yet. But the way that Shredder is built, it's in R, it's an S3 method. So it's built for extension. So it's not going to replace posterior. It's not going to replace TidyBase at all. The idea of it is that you can add your own class of object and then add your own code around it. So it can feed into it. So any package or any class that you want to add, it's going to be able to extend it.
Yeah, and so like if I wanted to extend it, like how big is the interface I need to implement on my own object if I wanted to interface with Shredder?
So let's say right now out of the box there's RStan and BRMS that's in there. So the main difference between BRMS and RStan and for Shredder is that it's going into the BRMS object and plucking out things from the nested fit inside the BRMS. So all I had to do was locate where the fit object was in that. And then once you get to the fit object, it's exactly the same internal pieces as RStan.
So if I like have a bigger object that is a fit object, then I just like write a method that like takes the fit object from inside, and I'm ready to go with Shredder.
Exactly.
That's nice. Yeah. Okay. So.
But the main benefit is the readability of the code. That, in my opinion, it's instead of using the arrays or the traditional ways that RStan has been used, even to get the names of the parameters, it's a bit more pipeline oriented. So you can iterate over different ideas that you have or different models. So that's another big benefit of it.
Yeah, and so there's one last from Oriol Abril is in addition to parallelization with PER, can Shredder be used like to distribute computing to instead of thinning? So if I understand it correctly, my interpretation is that like if you could like use Shredder to give slices of the posterior to multiple computation nodes. That's how I interpret it. I hope I interpret it correctly.
So you could do that. There's two ways with parallelization. Either you split out into a subset of different tasks that you want to do and then parallelize over the different tasks. So you're doing multiple things at the same time, or you do same thing over multiple models in parallel. Or I've done this in the past where you slice up the fit itself into pieces, and then you can distribute that and then connect them back later after you do some kind of post-processing. So yeah, you can do that.
Okay, thank you very much for your time, and especially for the Shredder package. You can find Jonah at a table later, so please do, and ask him all the other questions. And I'll have Ben as the last discussant today. Do we have Ben? Okay, so hi Ben. I really like the talk, and I guess you said like the most words in your talk of all the talks I've watched. So that was fascinating. And just to get this started, if I for example fit a gamma distribution, so you start with quantiles. So if I just have like very vague prior information, I just have to like lower 5%, upper 5% quantiles known, and say like I know it's lower bounded at 0, so I use a gamma distribution, and versus I use the no-name distribution you've shown with these same input information. So is there something in principle that I'm getting, or is just like your approach is way more general than like, you know, figuring out the parameters for gamma and then having a different method to figure out parameters for log normal and, you know, all sorts of things?
Yeah, if we had the gamma CDF implemented in Stan, you could do that, which we don't. But if we should, and once we do, you could do that. What I think is the advantage is you can go from 2 fixed quantiles to 3 fixed quantiles. Whereas if you try to put 3 quantiles with the gamma, you only have 2 parameters to deal with. So it's not going to be able to go exactly through 3 quantiles that you give unless you go up to generalized gamma distribution that has 3 parameters. And so you can do these sorts of things, but as you get like generalized of the common distributions, they get harder to work with. Whereas, you know, 3 quantiles of a no-name distribution is not really harder than 4 or 2. So that's where I think it's different.
Yeah, okay. So I think there's a very interesting question from Sarah. So how would you use the quantile function if you wanted to put a prior on some notion of sparsity of parameters like all the shrinkage priors do?
Mm-hmm. So for something like that, you want maybe a little bit of probability near 0, a lot of probability far from 0, but in the neighborhood of 0, you really want to concentrate on 0. And so the way in which to accomplish something like that from a quantile perspective is when the quantile curve relating the quantile to the cumulative probability gets flat, that's when you're going to have a lot of concentration on that value. So you would need to specify, you know, like a 0.52 quantile and a 0.48 quantile that are pretty close together in order to make that flatness in the inverse CDF curve. And then you can get a lot of concentration on zero. And, you know, whether you want to make that 0.52, 0.48, or 0.55, 0.45 affects, you know, how much of the concentration that you're going to get. But you could definitely represent these heavy-tailed, high kurtosis at zero distributions using quantile functions.
Yeah. So there's a good question from Chris. So he got lost a bit on the Chebyshev approximation, and so do you think it's like the best way, or is just like one example of how to build this, and there are many other approximations that could be used in a similar manner?
There are other ways to do it in a similar manner. I believe the numerical analysis literature on, like, if you had a known function that was difficult to evaluate, it was expensive, not explicit, something like that, and you wanted to approximate it with a polynomial over a closed interval, like 0 to 1, then the Chebyshev polynomials are essentially optimal among the class of polynomials. But if you don't have a distribution in mind, you just want to define the distribution by the quantiles, you can do that with Chebyshev. You can do it other ways as well. Spline, monotonically increasing spline, things like that. Also the metalog distribution.
Yeah. And so there's also this question from Dima mentioning the metalog. So could you use these quantile parameterized distribution as a representation of posterior for cases when, for example, you want to do a two-step process where you fit one model and take the posterior to use in the second model because you are unable for some reasons to fit the bigger model together?
Yes, you can use it to summarize posterior density or posterior draws into a distribution. You just need to, again, make sure that that's a strictly increasing function. And so you need to give it enough quantile information in order for it to accurately reflect the distribution, but that's not usually going to be that difficult if you have, 4,000 draws with which to make quantile estimates.
And so one of the things you mentioned is that it's hard to ensure, well, it doesn't always result in a monotonic approximation. So do you think there are like some possible transformation to do this, or do you think that's not like a super useful way to do this? Have you played with something like this, or maybe should people that listen right now try to play with this and figure out some transformations that would work in this way?
I encourage people to play with it. It's not so much the transformation, it's that, and I think this is, when I did this with my students, kind of the biggest obstacle is you'll get an error message saying what you tried to define does not define an increasing function. Try again. And so what you need to do in those situations is to add more quantiles in the regions where it tries to go down to make sure it stays strictly increasing over the whole range. And hopefully the code on the repository allows you to do that. But like I mentioned before, an alternative would be a monotonically increasing spline through the points that you give, which would never encounter that error, but it's not necessarily going to be as smooth a function as what Chebyshev or Metalog yields.
Okay. Yeah, so there are also some questions on the implementation in interfaces, and I'm not sure like if you're the right person to ask. So are you personally planning to like work on implementation, or do you just like suggest others? This is like a toy and you can play with it, and others should implement it, or?
Yeah, we're going to be applying next week for a grant to implement these sorts of things in Stan, but that shouldn't stop other people from contributing.
Okay, so there are other good questions. We're running out of time, but
lightning round.
Yeah, so please do find them at a table. Yeah, thank you very much, Ben, for your time. And so we're heading into our virtual coffee break and poster session with one poster, which is a big one.
Yep.
So
yeah.
So you wanna introduce the coffee break?
Yeah. Thank you to all the speakers and to you, Martin. The third session will open in 5 hours. In the meantime, I encourage you to chat with the other attendees as you would at a physical conference. Just find a table, sit down and talk to people. A lot of people here are friendly and from all over the world. There are tables laid out with topics that we hope will bring like-minded people together. And there are also tables with the name of the presenters and the poster. Go to those tables, sit down. One bit of Remo etiquette, try not to block a table. Please leave one seat open. Otherwise, no one else can get into the conversation. Thank you. See you.